The universe stretches outward like an endless blackened ocean, an abyss without shore, where stars are the only lanterns burning against eternity. Each pinprick of light is a sun, each sun a stage upon which worlds may rise and fall, perhaps even cradle minds that look outward as we do now. And yet, in all this immensity, there is only silence, a silence so complete it unsettles the soul. This silence frames a question as old as our wonder itself. If the cosmos is crowded with worlds, with time and opportunity enough to seed countless civilizations, then why does the night remain so empty? Why do we not hear their voices, their signals, their machinery echoing across the void? Is the question that physicist Enrico Fermi once gave a name, the Fermi paradox, a mystery that lingers like a shadow on the edge of every search for life beyond Earth. And then something arrives, a wanderer not of our solar system but from the deep interstellar gulf, a fragment of elsewhere, cold, silent and unfamiliar. Astronomers will call it Three-Eye Atlas. It is not alone. Others have come before it. First ʻOumuamua, then Borisov, each one a messenger from another star passing briefly through our cosmic neighbourhood before vanishing back into darkness. What are they? Shattered remnants of planets torn apart in distant cataclysms? Or could they be relics of something more deliberate? Machines, monuments, or tombstones adrift in eternity? And deeper still, could these visitors carry not just scientific intrigue, but an answer, an unsettling answer, to the most haunting question of all: where is everybody? In the summer of 1950, in the dry heat of Los Alamos, New Mexico, a group of physicists gathered for lunch. Among them was Enrico Fermi, a man whose brilliance had already reshaped physics and altered the fate of nations. As conversation wandered from scientific projects to the question of extraterrestrial life, Fermi, with sudden clarity, asked a question so deceptively simple that it cut deeper than any calculation. Where is everybody? It was not the first time humans had wondered about other worlds. Philosophers of Greece, poets of Rome, astronomers of the Renaissance, each had speculated on the multiplicity of worlds beyond Earth. But never before had the question been framed with such brutal precision. For Fermi's age was not one of speculation, but of equations and probabilities, of a new science stretching far beyond Earth's skies. Humanity had begun to understand the scale of the galaxy. By mid-century, astronomers already knew the Milky Way contained hundreds of billions of stars. Today, that estimate has sharpened, some 200 to 400 billion suns, many of them orbited by planets. The discovery of exoplanets in recent decades has confirmed what was once only a dream. Worlds are not rare jewels, but common stones scattered everywhere. NASA's Kepler mission revealed that Earth-sized planets orbit in the habitable zones of countless stars. Statistically, tens of billions of Earth-like worlds may exist in our galaxy alone. The numbers seem overwhelming. If even a fraction of those planets gave rise to life, and if even a fraction of those life-bearing worlds advanced to intelligence and technology, then the night sky should not be silent. It should be alive with signals, probes and signs of civilizations that rose before ours. And yet, there is nothing. For more than half a century, the search for extraterrestrial intelligence, SETI, has pointed radio telescopes into the void, listening for whispers of alien transmissions. The silence has been absolute. No beacons, no messages, no trace of machinery orbiting nearby stars. The contradiction is stark. Probability suggests abundance. Observation reveals emptiness. This is the Fermi paradox. It is not merely a curiosity, it is an existential riddle. If life is common, civilizations should be everywhere. And if civilizations are everywhere, some should be old, powerful, and expansive. With billions of years of head start, they should have crossed the galaxy, leaving traces upon every world, every system, perhaps even upon Earth itself. Yet there is no evidence, no artifact, no visitor. Just silence stretching across light years like an endless desert. This desert is not merely quiet, it is unnervingly quiet, for silence itself is data. Silence demands an explanation. Some propose the simplest answer: perhaps we are alone. Life may be an improbable accident, a chemical fluke so unlikely it happened only once in the visible universe. In this view, Earth is not just a planet, it is a singularity of biology, an oasis with no equal. But such an answer raises its own unease. For if we are alone, the universe is not only empty of voices, it is empty of meaning. Others propose that life is common, but intelligence rare. Microbes may fill countless oceans under alien suns, But few ever rise to self-awareness, fewer still to technology. Civilizations may be as rare as sparks in a storm, bright, brief, extinguished before their light can travel far. Yet another possibility is darker still. Perhaps civilizations arise, but they do not endure. Perhaps the galaxy is filled with the ruins of once living worlds, their inhabitants silenced by their own inventions, by cosmic disasters, or by the weight of time itself. If this is true, then the night sky is not empty, it is haunted. Haunted by civilizations whose voices have fallen quiet, leaving only drifting debris to testify they once existed. This possibility is what some call the Great Filter. Somewhere along the path from chemistry to complexity, from tool to technology, there lies a barrier that few, if any, cross. It may lie behind us, in which case we are survivors of a nearly impossible chain of chance. Or it may lie ahead, in which case our silence is explained, but at a cost we dare not name. And yet, the paradox deepens, for in recent years, interstellar objects have been discovered passing through our solar system: ʻOumuamua, Borisov, and now 3i Atlas. Fragments from the other systems are slipping quietly through the night. They are the first tangible visitors from beyond. Not signals, not probes, but more ancient shards of alien worlds. Their presence whispers of abundance, of countless planetary systems throwing material into interstellar space. If planetary systems are this active, then life too should be common. And so Fermi's question grows sharper, not weaker. With such evidence of cosmic richness, why does the silence remain? The Fermi paradox is not a puzzle that can be solved in a single equation. It is a shadow that lengthens with every new discovery. Each exoplanet, each interstellar object, each glimpse of cosmic possibility makes the paradox more profound. And so humanity stands at a precipice of knowledge and ignorance. Surrounded by billions of suns, with instruments tuned to the faintest signals, we hear nothing but the echo of our own transmissions. The paradox is not just a scientific curiosity, it is a mirror held up to our existence, for it asks not only where others are, but what we ourselves may become. Will our voice one day join the silence? Will we too fade, leaving only fragments drifting between the stars? Or does the paradox conceal a deeper truth, that in this vast and ancient galaxy, against all odds, we are first? The Fermi paradox lingers like a ghost at the edge of human thought. Every discovery brings us closer, yet the silence endures. And in that silence lies perhaps the most haunting truth of all, that the universe may not be empty, but waiting for us to understand what silence really means. For centuries, the solar system seemed like a sealed domain. The planets, their moons, the comets and asteroids that circled the sun, all were bound by gravity's invisible chain. Though the stars beyond glittered with promise, their distances were measured in light years, their mysteries unreachable. Humanity's telescopes strained against this cosmic boundary, searching for hints of other worlds, but the solar system itself appeared self-contained. That illusion shattered in October of 2017. At the Haleakala Observatory in Hawaii, a telescope designed to scan the skies for near-Earth asteroids caught a flicker of motion. A faint point of light, no brighter than a minor star, appeared against the background of the Milky Way. At first, it seemed like just another asteroid or comet drifting within the sun's grasp. But when its path was traced, the truth became undeniable. This object was not of our system. Its trajectory was hyperbolic, too fast and too steep to be held by the sun's gravity. It had come from elsewhere, from the dark gulf between stars. Astronomers named it ʻOumuamua. In Hawaiian, the word means a messenger from afar arriving first, and indeed it was the first confirmed interstellar visitor ever recorded. Its presence sent a shockwave through astronomy. For decades, theorists had suggested that interstellar objects must exist. Planetesimals flung away during the violent birth of planetary systems, wandering eternally through the galaxy. But the expectation was that they would be rare, elusive, invisible to all but the most powerful instruments. Few believed one would be found so soon, and certainly not one as strange as ʻOumuamua, for this messenger did not behave like anything known. Its shape was elongated, perhaps cigar-like, perhaps pancake flat, no one could say with certainty. Its brightness fluctuated dramatically, as though it were tumbling through space. More unsettling still, its trajectory deviated slightly from the expected path, as if some unseen force were nudging it outward. Comets often exhibit such accelerations driven by the vaporization of ice. Yet ʻOumuamua showed no coma, no tail, no plume of gas. It seemed to move under an invisible hand. The discovery ignited fierce debate. Was ʻOumuamua a comet? Its volatile material too faint to detect? Was it a fragment of rock, shattered from a world destroyed by gravitational tides? Or could it be something wholly different, perhaps even a construct, artificial, sent across the Gulf for reasons unknown? The astrophysicist Avi Loeb suggested it might be a thin reflective sail, the discarded technology of another civilization. Others dismissed the idea, insisting the evidence could be explained by natural processes. Yet the truth remained out of reach, for ʻOumuamua had already passed beyond the reach of our telescopes, vanishing into the night from which it came. The mystery might have remained an isolated enigma. But just 2 years later, in 2019, another messenger arrived. This time the object was unmistakable. Discovered by amateur astronomer Gennady Borisov, it bore the clear signature of a comet. Surrounded by a glowing coma, trailing a thin curved tail, 2I Borisov left no doubt about its nature. Yet its orbit too was hyperbolic. It was an interstellar traveller, carrying within its icy body the chemical fingerprints of another star system. Unlike ʻOumuamua, Borisov could be studied in greater detail. Telescopes across the world turned to follow it, and instruments detected cyanide gas, carbon monoxide and dust, substances familiar from comets within our own solar system. In many ways, it appeared ordinary, as though comets were universal building blocks formed under common rules of chemistry and physics throughout the galaxy. And yet its presence confirmed something profound. Interstellar visitors were not impossibly rare. Within only 2 years, humanity had detected 2 of them. Then in 2019, another faint light entered astronomers' view. The asteroid terrestrial impact last alert system, ATLAS, caught a fragmentary traveller, soon recognised as 3I Atlas, the third confirmed interstellar object. Unlike Borisov, it was fragile, breaking apart as it neared the Sun. Its disintegration suggested a cometary nature, an icy relic unable to withstand the heat of our star. Though its life as an intact body was brief, its message was unmistakable. Interstellar objects are not anomalies. They are part of the fabric of the galaxy. With each new arrival, a pattern began to emerge. What was once theoretical had become undeniable. Our solar system is not an island isolated in the void, but a shore upon which the tides of the galaxy occasionally wash debris from distant worlds. The implications are staggering. If 3 such objects have been found within just a handful of years, then the galaxy must be filled with them. Astronomers now estimate that trillions of interstellar objects may drift through our solar system every year, most too faint or too small for us to notice. Only with the advent of wide-field surveys and advanced telescopes are we beginning to catch them in passing. Each one is more than a curiosity. Each is a fragment of history, a shard from a distant planetary nursery, a remnant of processes that mirror our own solar system's violent beginnings. Some may carry within them organic molecules, the seeds of life flung outward by cosmic chance. Others may be the wreckage of shattered worlds, silent testaments to forces that shape not only planets but civilizations. And so the paradox deepens, for the very existence of these visitors suggests abundance. Planetary systems across the galaxy are not quiet, they are dynamic, violent, creative and destructive. If the materials of planets are everywhere, if fragments of alien worlds drift freely between the stars, then life too should arise often. And if life arises often, why is the night sky so silent of voices? The arrival of interstellar objects does not answer the Fermi paradox. Instead, it sharpens it. These messengers whisper that the galaxy is alive with activity, yet they carry no signal, no inscription, no clear evidence of minds behind their journeys. They are mute witnesses, fragments with no testimony beyond their presence. But even silence can be meaningful, for within these fragments may lie chemical signatures, isotopic ratios, and organic residues that reveal stories of distant systems. Already, Borisov has shown that the chemistry of comets may be universal. ʻOumuamua, in its strangeness, has hinted that the unexpected may be far more common than assumed. And Atlas, in its fragility, has reminded us that interstellar wanderers are not rare, they are plentiful yet ephemeral. Their arrival marks the beginning of a new chapter in astronomy, Telescopes like the Vera C. Rubin Observatory, soon to scan the skies with unprecedented depth, are expected to reveal many more. Each detection will add to the growing tapestry, each a thread connecting our solar system to the wider galaxy. Perhaps one day a future probe will be launched to intercept such an object before it vanishes back into the dark. To touch the surface of an interstellar fragment would be to touch another star system, to hold in human hands material that once orbited a sun far from our own. It would be a form of contact, if not with another civilization, then with the wider processes that shape life's stage. For now, the messengers pass in silence. ʻOumuamua tumbling into darkness, Borisov trailing gas into the void, Atlas dissolving into fragments beneath the sun, three voices, none human, none alive, yet each telling us that the stars are not distant fortresses. They shed their pieces freely, and those pieces find us. The arrival of interstellar objects is both a revelation and a question. They prove that the solar system is not alone. They hint that worlds are many, and they force us to return once again to the paradox that haunts every glance at the night sky. If the galaxy is so rich in planets, so generous in debris, so abundant in possibility, then where is everybody? In the fading months of 2010, as Earth orbited through its familiar path around the Sun, a telescope system in Hawaii turned its gaze toward the stars. The Asteroid Terrestrial Impact Last Alert System, or ATLAS, was built for vigilance. Its mission was not exploration in the romantic sense, but protection, an automated guardian designed to detect asteroids that might one day strike Earth. Night after night, its cameras swept across the heavens, mapping shifting points of light, flagging those that moved against the background of stars. Among those moving lights, one caught its attention. Faint, unremarkable at first glance, it seemed another comet falling toward the Sun. But as astronomers studied its orbit, the truth emerged. This object did not belong here. Its velocity, its trajectory, its inbound path, all told a story of origin beyond the solar system. Like ʻOumuamua and Borisov before it, this body was a traveller from the interstellar gulf. Its official designation would soon be recorded in history: 3I Apo Atlas, the third known interstellar object. The significance was immediate. In only 3 years, humanity had confirmed not one but 3 wanderers from the stars. What had once seemed improbable, the detection of even a single interstellar object within a human lifetime, was now a pattern. The galaxy, it appeared, was far more generous in sharing its fragments than once imagined. Yet Atlas was not like its predecessors. Unlike Borisov, whose cometary tale painted an unmistakable signature, or ʻOumuamua, whose bizarre acceleration invited controversy, Atlas was fragile. As it approached the Sun, its body disintegrated, breaking into pieces before it could be studied in detail. By the time its trajectory was fully mapped, much of it had already dissolved, scattering shards into interplanetary space. Its breakup told astronomers something profound. Interstellar objects are not monolithic survivors, hardened against eternity. Many may be fragile, transient, vulnerable to the same forces that shape comets within our own solar system. They are not eternal messengers, but perishable ones. Ice, dust, and rock wandering for millions or even billions of years, only to vanish in the heat of a foreign star. The trajectory of Atlas deepened the mystery. Calculations suggested it had entered our system at high velocity, on a hyperbolic path consistent with an interstellar origin. It was not bound to the Sun. No matter what fragments remained, they would eventually drift back into the dark, carrying with them a story that humanity only glimpsed in passing. Its angle of arrival traced backward into the constellation Lynx, though no specific star could be identified as its birthplace. Such is the nature of interstellar wanderers. Their journeys span so long, their encounters with other stars so frequent, that tracing them to a single origin becomes impossible. They are citizens of the galaxy itself, not emissaries of a single system. For astronomers, Atlas was extraordinary, not because it lasted, but because it vanished. In its disintegration lay a glimpse into the fragile architecture of interstellar debris. If such objects are common, many may arrive already fractured, their surfaces weathered by cosmic rays, their cores weakened by untold ages in the cold. What we observe, then, are not pristine samples of alien systems but relics worn down by the trials of interstellar travel. The chemistry of Atlas remains largely unknown. Its brightness curve suggested a cometary nature, rich in volatile ices. The breakup itself hinted at internal weakness, perhaps layers of dust and frozen gases loosely bound together. Though telescopes caught glimpses of its fading form, its rapid decline denied scientists the chance to study it as deeply as Borisov. In that sense, Atlas was a messenger whose voice was muffled, whose story was whispered and then lost. And yet, even silence can reveal truths. The very fact of its disintegration adds weight to the idea that interstellar objects are more varied than we imagined. Some may be solid rocks like asteroids, ejected from the violent collisions of forming planets. Others may be fragile comets, flung outward from icy belts and clouds surrounding alien stars. Still others may be fragments of catastrophic events, worlds shattered by tidal forces, moons cracked by gravitational upheaval, remnants cast outward into eternal exile. In Atlas, astronomers saw confirmation of a cosmic principle: the galaxy is not static. It is a place of continual motion, exchange and loss. Planetary systems do not hoard their material, they shed it. Each star is a fountain, releasing comets and asteroids into interstellar space, where they wander indefinitely until, by chance, they cross another star's domain. For humanity, Atlas was more than a scientific curiosity. It was a reminder of scale. In the great ocean of the Milky Way, our solar system is but one archipelago. Debris from distant shores drifts to us, fragments of worlds we may never see, bearing witness to processes universal and ancient. When such fragments appear, we are offered a fleeting chance to touch the wider galaxy, not with hands, but with eyes, with instruments, with thought. But there is also a philosophical weight. Each interstellar object raises a question more profound than its physical nature. If the galaxy can send us shards of alien systems, could it not also send us relics of civilizations? Could some of these fragile messengers be the debris not only of worlds, but of minds? The idea remains speculative, unproven and controversial, yet the possibility lingers, sharpened by the mystery of the Fermi paradox. For if civilizations do not endure, their ruins may drift as silent testaments, indistinguishable at first from natural debris. 3i Atlas stands then as a symbol of both knowledge and absence. It confirmed the reality of interstellar objects as a class. It demonstrated their fragility, their impermanence. It reminded astronomers that the galaxy is filled with wanderers far more numerous than once believed, and yet it left no clear answers, only the echo of a question first asked by Fermi. If the galaxy is so full of matter, so alive with worlds and fragments, why is it empty of voices? When Atlas disintegrated, humanity lost a chance to know it fully. But perhaps that is its lesson. The galaxy offers its messengers briefly, then withdraws them. To catch them, to study them, to learn from them, we must be ready. The night sky is not silent because it is empty. It is silent because its messages are fleeting, whispered once and gone forever. And so 3i Atlas became not only the third interstellar object ever observed, but also a harbinger. It told us that these arrivals will continue, that the solar system will not remain untouched, that other fragments, perhaps even more extraordinary, are on their way. The mystery of 3i Atlas does not lie solely in its physical form. It lies in its symbolism, a fragile wanderer appearing suddenly, breaking apart and vanishing back into the dark. Like civilizations themselves, it was brief, and like the paradox that haunts us, it left behind not answers, but questions. For centuries, the stars seemed like distant islands, separated by a void too vast for even the smallest pebble to cross. Astronomers looked upon the solar system as a kind of closed garden, where every comet, every asteroid, every grain of dust was born beneath the dominion of the sun. What lay beyond the heliosphere, the invisible boundary where solar winds yield to the pressure of interstellar space, was thought to be unreachable, unknowable, and sealant. And yet, quietly, theorists knew this vision could not be complete. For planetary systems are not gentle in their formation. They are born in chaos. Young suns ignite amid swirling disks of gas and dust, and planets grow by collision, slamming together in violent accretion. Comets and asteroids are flung outward by the gravitational pulls of newborn giants tossed into exile at incredible speeds. In this cosmic tumult, many fragments escape entirely, severing the tether of their parent star to drift freely in the interstellar abyss. Mathematics suggested there must be countless such wanderers. Even a modest planetary system should eject trillions of icy bodies during its formation. Multiply that by the billions of stars in the Milky Way, and the galaxy should be flooded with interstellar debris, rogue comets, asteroids, and fragments adrift between suns. But though the reasoning was solid, there was no proof until 2017. The discovery of ʻOumuamua broke open the wall between theory and reality. Here, at last, was not speculation but observation, a real fragment, moving too fast and at too steep an angle to belong to the Sun. Its very presence confirmed what had been imagined for centuries. Objects do not remain bound to their birthplaces. They wander, unmoored, like castaways in a sea of stars. The shock came not only from its existence, but from its detection. For astronomers had long assumed such objects would be exceedingly rare to find. A single interstellar visitor passing within range of Earth's telescopes might occur only once in hundreds of years, or so it was thought. The odds seemed stacked against seeing one at all, and yet ʻOumuamua arrived, slipping past Earth almost unnoticed, its faint glimmer caught only because modern surveys were finally watching the skies with tireless vigilance. If one could be found so soon, what did that mean? Were they not rare after all? The question deepened in 2019 with the arrival of Borisov, a comet unmistakably foreign, carrying within its icy shell the chemistry of another system, shining brightly enough to be tracked in detail. Within the span of just 2 years, 2 interstellar objects had been confirmed, and then, within months, came Atlas. 3 wanderers, each unique, all detected in rapid succession. The realization struck with the force of revelation. Interstellar objects were not scarce, they were common, perhaps unimaginably, so astronomers began to recalculate. If surveys like Pan-STARRS and Atlas, limited by time, sky coverage and sensitivity, could detect 3 in such a short window, then the true population must be vast. Estimates emerged suggesting that trillions of such bodies pass through the solar system every year. Most are too small, too faint, too swift to be noticed. But they are there, flowing through like an invisible current, as ordinary as the dust that gathers on Earth's winds. This was the first shock. Not simply that interstellar objects exist, but that the galaxy may be saturated with them. The empty void once thought sterile now appeared littered with fragments. The solar system is not isolated, shaded, not walled off, but porous, open to a constant exchange of debris with this wider galaxy. For planetary science, the implications are profound. Each interstellar object is a sample, a messenger carrying material forged beneath an alien star. Within their composition lies evidence of how other systems form, how they differ, how they resemble our own. The presence of Borisov's cyanide gas and carbon monoxide revealed that cometary chemistry may be universal. Even more tantalizing is the possibility that some may carry organic molecules, the seeds of life itself. The panspermia hypothesis, once fringe speculation, now finds in these wanderers a plausible vehicle. If fragments can drift between stars in such abundance, perhaps life's building blocks too can cross the gulf, spreading like spores through a cosmic forest. But the shock is not only scientific, it is philosophical. For if interstellar debris is this common, then the galaxy is far more active than silence suggests. It is not an empty desert, but a place of continual exchange. The paradox grows sharper. How can a galaxy so rich in planetary fragments, so noisy in the language of collisions and ejections, be so mute when it comes to civilizations? If matter flows so freely, why not signals? Why not machines? Why not them? The detection of multiple interstellar objects in such a short span redefines the night sky. It suggests that at any given moment, unseen travelers slip past us, but remnants of distant worlds passing close enough to glimpse but never stopping. They are cosmic refugees, carrying within them the memory of systems long separated from ours. Each one is extraordinary not for its strangeness alone, but for its sheer existence, for its testimony that the galaxy is not still, but restless. In the silence of the Fermi paradox, this restlessness matters. It tells us that the cosmos is alive with movement, with exchange, with connection on a physical level. But it also confronts us with a deeper truth, that messages, if they exist, may not come as radio signals beamed deliberately across the void. They may come instead as fragments, mute, drifting and fragile, evidence not of presence but of absence, not of civilizations alive but of civilizations gone. The first shock was not only seeing an object between stars, it was realizing that we may be surrounded by them, that every year thousands slip past unnoticed, that the solar system is not alone, but constantly visited by wanderers whose stories we barely hear. And in this shock lies both wonder and unease, for each interstellar object proves that the galaxy is connected, and each, by its silence, reminds us that even in a galaxy of abundance, the question remains, where is everybody? The universe speaks in numbers, and often those numbers whisper truths too vast for the human mind to easily grasp. The discovery of 3 interstellar objects within just a few short years, ʻOumuamua in 2017, Borisov in 2019, and Atlas not long after, was not merely a coincidence. It was a revelation, a statistical crack in the illusion of rarity. For if 3 could be glimpsed in so little time, how many more must pass unseen? Astronomy is, by nature, a science of inference. Telescopes catch only fragments of reality, faint traces of light, brief appearances against the night. From those traces, scientists construct models, weaving probability into prediction. In the wake of ʻOumuamua, researchers began to calculate. Using its size, its brightness, and the probability of detection by surveys like pan-stars, estimates were made of how many such objects must be coursing through interstellar space. The answer was staggering. By conservative models, there may be trillions of interstellar objects drifting through the Milky Way at any given moment. The solar system itself is not empty of them. Rather, it is constantly intersected by their passage. Some estimates suggest that at any given time, thousands of interstellar objects larger than 100 meters in diameter are moving within the orbit of Neptune, silently sharing space with us. Most are invisible, too faint, too distant, or too swift for even the most sensitive instruments to see. But they are there, like shadows crossing the floor of a vast cathedral unnoticed by those who do not look up. This realization is the statistical avalanche. 1 detection was remarkable, 2 suggested a pattern, 3 made it undeniable. Each new object multiplied the probability, pushing the estimates upward until the scale became overwhelming. The galaxy is not a void between stars, but a sea thick with debris. Each system sheds its remnants like leaves falling from a tree, and those leaves drift endlessly, scattered across light years, carried by gravity's invisible winds. Why then did it take until 2017 to see the first? The answer lies not in the absence of objects, but in the limits of vision. The night sky is vast, and interstellar wanderers are small. ʻOumuamua itself was no larger than a skyscraper, moving against a backdrop of billions of stars. For most of history, no telescope existed capable of catching such a faint, fast-moving light. Only with the rise of wide-field automated surveys, programs like Atlas, and Pan-STARRS, and soon the Vera Rubin Observatory, has humanity gained eyes sharp enough to notice what was always there. It is a humbling reminder of perspective. The universe did not suddenly begin sending us interstellar visitors. They have always passed through, generation after generation unnoticed. Only now, in the thin slice of history where technology aligns with curiosity, do we finally glimpse them. And with each glimpse, the enormity of their numbers presses harder upon us. This avalanche carries profound implications. If trillions of interstellar objects drift between stars, then every planetary system is in constant dialogue with its neighbours, not through voices or signals, but through fragments of matter. The solar system itself has likely shed its share of wanderers, ejected during its chaotic youth, now roaming the galaxy as silent ambassadors of our sun. Somewhere, perhaps, a distant civilization may have already observed one, cataloguing it as an interstellar object from an unknown system, never knowing it was born in the cradle of Earth's star. This exchange transforms our understanding of isolation. For even if civilizations are rare, planetary systems are not solitary. They shed pieces of themselves into the galaxy, and those pieces intermingle, passing through alien skies, dissolving in alien suns. The Milky Way becomes less a collection of isolated islands and more a vast archipelago, its oceans crisscrossed with drifting relics. And yet, there is an unsettling undertone. If these fragments are so common, then they may also represent not only the birth of systems, but their destruction. Trillions of shards scattered across the stars may not all be youthful debris from planetary nurseries. Some may be the remnants of cataclysms, the rubble of worlds shattered, moons torn apart, even civilizations reduced to fragments by forces indifferent to their existence. Each interstellar object is a statistical inevitability, but it is also a possible gravestone. The avalanche does not discriminate between beginnings and ends. The scale also forces us to reconsider the Fermi paradox. The silence of radio telescopes once seemed puzzling in a galaxy where civilizations should be abundant. But the flood of interstellar debris reframes the question. If fragments of planets are everywhere, why have none yet revealed unmistakable signs of technological origin? Why do none glimmer with metals or alloys? None travel on guided trajectories, none break apart to reveal engines or inscriptions. The abundance of natural messengers only sharpens the absence of artificial ones. The avalanche of rocks becomes, paradoxically, an avalanche of fragments. Still, humanity stands at the threshold of a new era of detection. The Virasi-Rubin Observatory, set to survey the sky with unprecedented depth, is expected to find dozens, perhaps hundreds, of interstellar objects in its first decade. Each new detection will refine the statistics, narrowing the uncertainties, revealing not only how common such wanderers are, but what variety they embody. Some may resemble ʻOumuamua, enigmatic and unclassifiable. Others may echo Borisov, comets carrying familiar chemistry. A few may surprise entirely, breaking categories, rewriting models. With each addition to the avalanche, our picture of the galaxy sharpens. We begin to see it not as an empty gulf, but as a living system of exchange. And in that picture lies a kind of quiet awe, for while civilizations remain hidden, planetary fragments do not. They arrive without fanfare, without signal, without intent, yet they testify to a universe restless, creative and interconnected. The statistical avalanche is more than a calculation. It is a revelation of scale, a reminder of how easily the human mind underestimates abundance. We thought interstellar objects would be rare. Now we see they are countless. We thought the solar system was self-contained. Now we see it is porous. We thought the void was empty. Now we see it is filled with wanderers, each carrying stories older than humanity itself. But the avalanche is also a mirror. For if natural fragments are so numerous, then perhaps the true rarity lies not in matter, but in mind. Perhaps civilizations are the exceptions in this sea of abundance. And perhaps the silence is not paradox at all, but expectation, that among trillions of fragments only one carries thought. And for now, that one is us. The galaxy is restless. Around every newborn star a chaos unfolds. Worlds in the making colliding, fragments torn away, icy bodies hurled outward into exile. Out of this violence, planets take shape, and out of planets, the possibility of life. But the violence does not end there. It continues endlessly, scattering debris like embers from a fire, flinging trillions of fragments into the cold between suns. For centuries, astronomers imagined such wanderers, but only in 2017 did one finally appear. ʻOumuamua, its passage, though brief and enigmatic, forced a question into the scientific conversation. Are these objects merely cosmic debris, the rubble of planetary systems, or could some of them be something more? Silent messengers from civilizations we have not yet met. The natural explanation is the most conservative. ʻOumuamua, Borisov, and Atlas may all be products of ordinary astrophysical processes. Comets and asteroids are easily ejected during the early lives of planetary systems. Their abundance, now confirmed by observation, is no surprise to the mathematics of celestial mechanics. They are fragments, broken shards, cosmic driftwood scattered by tides of gravity. And yet, ʻOumuamua does not fit neatly into this picture. Its shape, elongated, perhaps flattened, was unlike anything seen in our solar system. Its strange acceleration, too subtle to be explained by known cometary outgassing, lingers as an unresolved mystery. While many scientists believe it to be natural and others have dared to speculate. Could it be artificial? A derelict probe, a fragment of some alien technology drifting silently after completing a mission? Or perhaps not a probe at all, but refuse, discarded material from an advanced civilization flung outward like our own space debris. The suggestion was made most prominently by Avi Loeb, who argued that ʻOumuamua's behavior might be consistent with a thin reflective sail, a structure propelled by starlight. a technology humans themselves are only beginning to imagine. His claim ignited debate, with most astronomers leaning toward natural explanations, but the very fact that such speculation entered the scientific record reveals how deeply these visitors unsettle our assumptions. For the line between natural and artificial is thin, and from across interstellar distances difficult to draw. Consider this. Humanity has already placed objects on interstellar paths. The Voyager probes, launched in the 1970s, are now drifting beyond the heliosphere, carrying golden records as messages to the stars. The Pioneer plaques, attached to earlier spacecraft, do the same. Even fragments of rockets, satellites, and debris have been ejected from Earth's grasp, destined to wander long after humanity itself is gone. To a distant observer, centuries or millennia hence, these relics might appear indistinguishable from natural debris, unless studied with extraordinary precision. If humanity can seed the galaxy with silent messengers in its infancy as a technological species, what might civilizations far older have left behind? Probes abandoned, machines forgotten, fragments of megastructures broken by time. If they exist, they would look much like comets, much like asteroids, except for the faint traces of intention buried within their form. This is where speculation meets philosophy. The Fermi paradox asks, where is everybody? If civilizations are common, why are they not visible? Perhaps the answer lies not in signals but in objects, not in radio waves but in silent stones. Perhaps the galaxy is littered with their remains, yet we cannot distinguish them from natural wanderers. The pshansi then may be deceptive, not absence but camouflage. And yet there is caution here. The principle of science demands restraint. Extraordinary claims require extraordinary evidence, and so far the evidence leans toward natural origins. ʻOumuamua's acceleration might yet be explained by exotic but natural processes, hydrogen outgassing, fractal geometry, or shapes not seen before in our system. Borisov's chemistry aligns with ordinary comets. Atlas disintegrated like many icy bodies do. Nothing requires an artificial hand, but possibility remains. If even one interstellar object were revealed to be technological, the implications would eclipse every other discovery in human history. It would mean that civilizations do exist, that they leave traces, that we are not alone. The Fermi paradox would no longer be a haunting silence, but a mystery transformed into evidence. For now, every interstellar object forces us to live in tension between two possibilities. On one side, debris, natural, countless, inevitable. On the other, messengers, artificial, rare, perhaps nearly extinct. Both answers are profound. If they are only debris, then the galaxy is filled with the ruins of planetary systems, but no voices. If some are messengers, then civilizations have spoken, but in a language we have not yet learned to read. The silence persists, but these fragments challenge its meaning. When ʻOumuamua slid past Earth, when Borisov dissolved in sunlight, when Atlas broke apart, they offered no signals, no engines, no inscriptions, but they carried questions, heavier than their mass. Each one a riddle, each one a whisper. Cosmic debris or silent messengers? The answer may not be either or, but both. The galaxy may be filled with fragments of countless worlds, the vast majority natural, but among them, perhaps a few, so rare, so precious that bear the fingerprints of intelligence. To find even one would change everything. And so astronomers continue to search. New telescopes will scan the heavens more deeply than ever before. One day a probe may be sent to chase an interstellar traveller, to study it up close, to touch the surface of a messenger from another star. If it is only rock and ice, we will have learned about the universality of worlds. But if it is more, if it is machine, relic or ruin, then humanity will have found its first answer to Fermi's haunting question. Until then, the objects drift past in silence. Natural or artificial, debris or messenger, each reminds us of the same truth. The galaxy is not empty. It is alive with motion, with fragments of stories untold. And somewhere, hidden among the countless stones, may lie the evidence that we are not the first to ask the question, where is everybody? In October of 2017, the first known interstellar object passed silently through the solar system. It was given a name that captured its mystery. ʻOumuamua, a messenger from afar, arriving first. For a brief moment in time, humanity found itself in the presence of something not born under the light of the sun, but in the fire of a distant star. At first, astronomers assumed it to be a comet or asteroid, familiar categories within the solar system. Yet almost immediately, ʻOumuamua defied every definition. It displayed no coma, no trail of vaporized ice, no signature that marked it as a comet. Its light curve, the pattern of brightness recorded as it tumbled, suggested a shape unlike anything seen before. It may have been elongated like a cigar, 10 times longer than it was wide, or perhaps a flattened disk, like a cosmic pancake spinning through space. Either way, its geometry was extreme, far beyond the range of ordinary asteroids. Then came the greatest anomaly of all. As it slipped away from the sun, ʻOumuamua accelerated slightly, just enough to deviate from the trajectory predicted by gravity alone. For ordinary comets, such accelerations are explained by jets of gas, expelled as sunlight warms frozen ices. But ʻOumuamua showed no visible jets, no dust, no tail. Its movement seemed to be propelled by an invisible hand. The astronomical community was divided. Some argued that it must be natural, a fragment of rock or ice with properties we simply did not understand. Perhaps it was a hydrogen iceberg, its surface evaporating invisibly. Perhaps its geometry allowed radiation pressure from the sun to push it outward without leaving detectable traces. Others proposed exotic explanations, fractured fragments of carbon-rich ices, or porous structures so light they responded like sails to starlight. But one voice suggested something far more provocative. Avi Loeb, a Harvard astrophysicist, proposed that ʻOumuamua might not be natural at all. In his view, its peculiar acceleration and extreme shape could be explained if it were a thin, flat object, perhaps no thicker than a millimeter, functioning as a light sail. Such a sail propelled by starlight pulse is a technology humanity itself has imagined. Projects like Breakthrough Starshot envision sending tiny probes across interstellar distances on sails of similar design. If humans can conceive such things now, Loeb argued, why could not another civilization have built one long before us? The hypothesis was controversial, unsettling, even heretical to some, for it suggested that humanity's first encounter with an interstellar object might not have been with a fragment of rock, but with the relic of a civilization, a probe, perhaps derelict, drifting silently for ages, or discarded technology, abandoned after serving its purpose. Most astronomers rejected the idea. The principle of scientific conservatism demands that natural explanations be exhausted before invoking the artificial. Extraordinary claims require extraordinary evidence, and ʻOumuamua offered no signal, no markings, no clear indication of design. Theories of exotic but natural origins remained far more likely. Hydrogen outgassing, though unobserved, could explain its acceleration. A fractal shard of nitrogen ice chipped from the surface of a Pluto-like world might behave in similar ways. To many, invoking alien technology seemed premature, even reckless, and yet the debate refused to die. ʻOumuamua was visible for only a short time, fading quickly as it retreated into darkness. No spacecraft could pursue it, no telescope could capture it in fine detail. All humanity had were a handful of observations spread across just a few weeks. The data were tantalizing but incomplete, enough to provoke questions, never enough to settle them. This incompleteness is what makes the ʻOumuamua debate so powerful. It is not only about what ʻOumuamua was, but about the boundaries of human imagination. How should science confront the unknown? Should it cling to the comfort of the natural, or allow room for the possibility, however slim, that something artificial has crossed our path? The divide reveals more about humanity than about ʻOumuamua itself. For some, the thought of alien technology in our midst is exhilarating, a validation of hopes that we are not alone. For others, it is unsettling, a leap too far beyond what the evidence supports. The tension lies not in the object itself, but in what it represents. The confrontation with the possibility that the Fermi paradox may not be a question of absence, but of misinterpretation. That the signs of civilizations may not come as radio waves or luminous beacons, but as silent and ambiguous fragments drifting past unnoticed. The debate also carries a subtle warning. If ʻOumuamua were artificial, it was silent. It broadcast no signal, made no approach, revealed no intent. It behaved not as a visitor seeking contact, but as debris, indifferent and uncommunicative. If such fragments are the relics of civilizations, they may not be signs of thriving societies, but of ruins. echoes of voices long silenced, their technologies adrift, purposeless in the void. Whether natural or artificial, ʻOumuamua sharpened the Fermi question. Its existence proved that the galaxy is connected, that fragments do cross the void. If matter can travel between stars, why not machines? If machines, why not probes? And if probes, why not evidence of civilizations? The silence grows louder in the face of these possibilities. ʻOumuamua is gone now, beyond the reach of telescopes, vanishing into interstellar space. Its secrets remain its own. Astronomers await the next messenger, armed with better instruments, hoping for longer windows of observation. Projects are even being proposed to build rapid response spacecraft, ready to launch at a moment's notice should another interstellar visitor appear. Perhaps the next will resolve the debate, perhaps not. But the memory of ʻOumuamua endures as a reminder of humility, for in its brief appearance it revealed the limits of certainty. Science thrives on data, yet sometimes the universe offers only fragments, and in those fragments lies ambiguity. The ʻOumuamua debate is, at its heart, a mirror, reflecting humanity's hopes, fears and biases onto the canvas of the unknown. Was it cosmic debris or a silent messenger? The truth remains hidden in the darkness, but its passage has changed the way we look at the stars. No longer do we ask only if civilizations exist. Now we ask, if they do, could we even recognize their traces? Would we mistake their ruins for rocks, their sails for shards, their messengers for debris? In the mystery of ʻOumuamua lies not only the story of a single object, but the story of how humanity confronts the unknown. And in that confrontation, the silence of the universe deepens, not as an absence, but as a question waiting to be answered. In the autumn of 20, astronomers once again noticed a faint moving light in the dark, a speck of brightness, shifting against the static canvas of the stars. At first it seemed unremarkable, just another comet drawn inward by the sun's distant pull. Yet as calculations refined its orbit, the truth emerged. It was not native to the solar system. Like ʻOumuamua before it, and Borisov only months earlier, this body was an interstellar traveller. Its name would soon enter the astronomical record, 3I Atlas, the third confirmed visitor from another star. But unlike ʻOumuamua, which slipped away intact, and unlike Borisov, which displayed the vibrant coma of a comet, Atlas did not endure. As it approached the sun, its nucleus fractured, breaking apart into smaller pieces. Observatories watched as its brightness fluctuated and declined, evidence that it was unravelling under the stress of its encounter. By the time it drew nearest to Earth, Atlas was already a remnant of itself, a dying traveller dissolving into dust and fragments. Its fragility spoke volumes. To drift between stars is not to wander in peace, it is to endure an ocean of violence. Interstellar space is not empty, but filled with hazards. Cosmic rays that bombard and weaken matter over millions of years, micrometeoroids that chip away at surfaces, the tidal forces of distant stellar flybys, and the silent stress of deep time itself. What enters a new star system is often not pristine, but weathered, scarred, and brittle. Atlas revealed this truth with its disintegration. Its structure was likely loose, a rubble pile of dust and ice only weakly held together by gravity. Within the cold of interstellar exile, it may have survived intact for millions of years. But as sunlight struck it, volatile ices sublimated, gas pressures built, and fractures widened. The warmth that illuminates our world was its undoing. This fragility resonates with a deeper meaning. For each interstellar object is a survivor of violence. To be cast adrift, it must first have been torn from its home. Some may have been ejected during the turbulent birth of planets, flung outward by gravitational encounters. Others may be the shattered remnants of larger worlds, broken by collisions or tidal forces. Atlas, in its frailty, was a reminder that the galaxy is a place of destruction as much as creation. The violence of interstellar space is a hidden backdrop to the Fermi paradox. If worlds are so easily fractured, if debris is so abundant, then perhaps civilizations themselves are equally fragile. For what are civilizations if not structures balanced against time and chaos, bound together by delicate forces of cooperation and stability? Like Atlas, they may endure for a time, but under the pressures of environment, entropy, or self-inflicted wounds, they too may unravel. Their remains, like fragments of a comet, may drift silently through the galaxy, mute testimony to what once was. Astronomers studying Atlas understood its value, even in disintegration. In its fading brightness were clues about its structure and composition. If it was cometary, its chemistry could reveal whether comets in distant systems resemble those of our own. Initial data suggested a richness in volatile ices, though the exact details were lost as the body disintegrated too quickly for thorough study. Unlike Borisov, which survived long enough for detailed spectroscopic analysis, Atlas slipped away, leaving only glimpses of its nature. Its shens, its incompleteness, was itself part of the lesson. The very fact of its breakup confirmed that interstellar wanderers are diverse. Not every messenger is resilient like ʻOumuamua, not every traveller luminous like Borisov. Some arrive weakened, fragile, already unravelling before they even meet the heat of another star. In this diversity lies a picture of the galaxy not as uniform, but as restless and varied, with each system producing different kinds of fragments, each subjected to different histories of violence. For humanity, Atlas was a reminder that what we see is only a fraction of what exists. Many interstellar objects may break apart before they are ever noticed, scattering dust into invisibility. Some may dissolve in the dark of interstellar space itself, undone by slow erosion long before they ever reach another star. The galaxy may be littered not only with intact messengers, but with invisible clouds of dust, the ashes of countless lost worlds. In this, Atlas becomes symbolic. It is not only an astronomical object, but a metaphor for impermanence. Nothing endures unchanged, not even the wanderers that drift between suns. They carry with them stories written in fractures and scars, stories that end in disintegration. Their journeys remind us that the cosmos is not a static stage, but a living theatre of birth and death, of creation and collapse. The fragility of Atlas also reopens the question of life's endurance. If fragments of planets are so easily destroyed, how much more precarious must life itself be? The forces that shatter comets can also strip atmospheres, sterilize surfaces, and extinguish ecosystems. If the galaxy is filled with debris, then it is also filled with danger. Civilizations may not only destroy themselves, they may be undone by the very violence that scatters fragments like Atlas across interstellar space. And yes, fragility is not only a story of destruction, it is also a story of resilience, for even in disintegration, Atlas carried knowledge. Its fragments dispersed, but in their brief visibility, humanity learned that interstellar comets exist, that they can be fragile, and that their diversity reflects the processes of distant systems. Fragility, paradoxically, becomes revelation. To study Atlas is to be reminded that survival is not guaranteed. The universe is harsh, time is long, and nothing is immune to entropy. But it is also to recognize that even brief appearances can alter understanding. In its fragile death, Atlas expanded the scope of human vision, and so 3i Atlas joins the list of cosmic messengers, not as the most dramatic, not as the most mysterious, but as the most fragile. It speaks not with endurance, but with dissolution. It teaches that worlds, like civilizations, may fracture, fade, and vanish, leaving only fragments behind. And those fragments, drifting silently across the galaxy, may be the only testimony that they ever existed at all. The silence of the stars has long been humanity's most persistent riddle. The equations suggest abundance, billions of suns, billions of planets, countless chances for life to arise, yet radio telescopes listen across decades and find only emptiness. The paradox that Enrico Fermi voiced in a single question, "Where is everybody?" has become the shadow that lingers over all of modern astronomy. The recent discoveries of ʻOumuamua, Borisov, and Atlas sharpened that shadow. They proved beyond doubt that material does not remain bound to its home star. The galaxy is not divided, but connected by rivers of debris flowing between systems. And in that revelation lies a disturbing possibility. If matter can travel so freely, then the silence of civilizations is no longer explained by isolation. It must be explained by something else. Perhaps civilizations do arise. Perhaps they build, expand, and dream of reaching the stars. But perhaps they do not endure. Their signals fade, their machines decay, their worlds fracture. What remains are not voices, but fragments. Comet-like wanderers that slip silently through the dark. In this interpretation, 3i Atlas is not merely a comet. It is a metaphor, a stand-in for the fragility of civilizations themselves. Fragile when born, vulnerable when tested, and destined in time to break apart. The disintegration of Atlas spoke volumes. Under the heat of the sun, it fractured and dissolved, undone by forces too great for its weak structure to withstand. Astronomers observed only pieces, scattering into invisibility. To some, it was a lesson in cometary fragility. But in the wider lens of the Fermi paradox, it was something more, a mirror held to the fate of civilizations. If even the bodies of stone and ice cannot endure the violence of the cosmos, what hope do cultures of flesh and fire truly have? The galaxy may therefore be full of civilizations that once existed, but whose endurance was cut short. Some may have succumbed to natural catastrophes, gamma ray bursts, supernovae, asteroid impacts. Others may have been undone by their own technology, consuming themselves before reaching interstellar maturity. Time itself may be the enemy, grinding down even the most advanced societies into dust. And as with Atlas, the record they leave may not be voices, but fragments, unintelligible to any who discover them. This possibility reframes the silence. The Fermi paradox may not be a puzzle of absence, but of ruins. What we hear is not emptiness, but aftermath. The radio silence of the stars is not because civilizations never existed, but because their lifetimes are fleeting, their endurance fragile, their remains drifting mute between suns. If this is true, then interstellar debris is more than natural rubble. It is also a record of cosmic mortality. Each shard that crosses our skies may be, in some distant sense, the ash of a world once alive. To imagine this is to see Atlas differently, not only as a comet, but as a symbol of impermanence. Its crumbling body is a quiet reminder that nothing in the universe is spared the forces of disintegration, not even civilizations that once reached for the stars. The unsettling weight of this idea is matched only by its plausibility, for the galaxy is old, over 13 billion years in age. If civilizations had arisen early and endured, their presence should now be unmistakable. Colonies should stretch across the spiral arms, signals should flood the radio sky, probes should visit every system. Their absence suggests not absence of origin, but absence of survival. Life may spark often, but like Atlas, it may not last. This perspective is sobering. It forces humanity to confront its own place in cosmic history. Earth is not exempt from the laws of fragility. Our species, like a comet, carries the potential to fracture under pressure, be it environmental, technological, or self-inflicted. If civilizations do not endure, then perhaps our own is no exception. And yet, even in this dark interpretation there is meaning, for ruins can still speak. The fragments of Atlas, though scattered, still carried information, clues to its structure, its chemistry, its origin. In the same way, the remains of civilizations may leave traces, subtle and silent, waiting to be recognized. A fragment of technology mistaken for rock, a drift of debris mistaken for comet dust. The galaxy may be speaking not in voices, but in relics, waiting for us to listen differently. The Fermi link then is this: interstellar debris like Atlas may be the only traces left behind by civilizations that could not endure. Their ashes cross the galaxy as mute testimonies to what once was. The paradox is not solved by abundance, but by fragility. The silence is not a void, but a graveyard. This idea does not end the mystery, but it reframes it. Humanity may never hear the voices of others, but it may already have seen their remnants, passing quietly through the solar system, misidentified as mere stones and ice. The challenge is not only to search harder, but to interpret differently, to learn to distinguish natural debris from artificial relics, to recognize when a fragment is more than it seems. For now, Atlas has already crumbled, his pieces lost to the interplanetary void. It left no answers, only questions, but in its brief appearance it offered a haunting reflection. Civilizations, like comets, are fragile, fleeting, and impermanent. Their voices may not carry across the stars, only their ashes may endure, drifting silently between suns. And so the link emerges. The Fermi paradox may not be answered by messages, but by ruins, by silent fragments like Atlas, by ashes in the dark. Across the darkness of the galaxy, countless fragments wander without name. Shards of ice, splinters of rock, dust scattered like ashes upon a cosmic sea. To many, they are only debris, ordinary byproducts of planetary birth. But in the deeper, darker interpretation, they may be more than rubble. They may be gravestones, markers of planets destroyed, of worlds erased, of civilizations undone. The violence of the cosmos spares nothing. Stars swell into red giants, devouring the very planets that once circled them. White dwarfs scorch their systems with searing ultraviolet light. Neutron stars release flares of radiation capable of sterilizing entire worlds. And supernovae, stellar deaths of unimaginable power, can strip atmospheres from planets dozens of light years away. Each of these events scatters material outward, fragments of what once was, flung into interstellar exile. But destruction is not only cosmic, sometimes it may be self-inflicted. Civilizations like comets may carry within them the seeds of their own disintegration. Wars, resource collapse, runaway technologies, forces born not of nature but of will. If they fall, they too may leave only fragments behind. Wreckage drifting silently between stars, indistinguishable from natural debris until studied with impossible care. In this haunting vision, interstellar objects like 3i Atlas become symbols not just of planetary systems, but of mortality itself. When Atlas disintegrated under the sun's heat, it was as though it carried a message. Fragility is universal. What seems eternal can fracture in an instant. A body that survived millions of years in the cold of space unraveled in a matter of weeks. So too might civilizations endure eons, only to vanish swiftly when pressures grow too great. Astronomers have already glimpsed worlds that bear scars of cosmic violence. Telescopes have detected exoplanets orbiting dead stars, their atmospheres stripped away, their surfaces scorched. In some cases, even the remains of shattered planets have been observed as rings of debris circling white dwarfs, worlds reduced to rubble by tidal forces. These are gravestones written in orbits and dust, proof that destruction is not theoretical but real. When such fragments escape into interstellar space, they carry with them the memory of loss. Not a conscious memory, but a physical one, inscribed in their composition, their fractures, their orbits. They are relics of annihilation, drifting forever. The galaxy may therefore be filled with these silent markers, testifying to the fragility of both planets and civilizations. The symbolism deepens when viewed through the lens of the Fermi paradox. If civilizations arise often, why are they not seen? Perhaps the answer is that their gravestones are all around us, but we have mistaken them for ordinary stones. ʻOumuamua, Borisov, Atlas, each could simply be natural debris, but if even one such fragment bore the subtle signature of technology, it would be enough to rewrite the story of the universe. For now, they remain ambiguous, but the possibility lingers like a shadow. Consider the timescales. Stars live for billions of years. Civilizations, if Earth is any measure, may exist for only thousands before they risk collapse. The odds are not kind. The chance of two civilizations existing at the same time, in the same region of the galaxy, is slim. But the fragments they leave behind, their probes, their debris, their gravestones, could persist for millions, even billions of years. In this sense, relics may be far more common than voices. Gravestone lasts longer than lives. 3i or Atlas then can be seen as one such tombstone, not literally, but symbolically, a fragment of a world that no longer exists, disintegrating as it passes through our system. Its sound becomes its message. Not all who wander are alive. Some of the dead carried endlessly by the currents of the galaxy. This perspective transforms how humanity views interstellar visitors. They are not only scientific curiosities, but also philosophical reminders. Each one may be a grave marker, an unmarked memorial to systems destroyed long before humans looked up at the stars. In this light, the universe is not empty but haunted, a vast cemetery where the dead drift without epitaph, their stories erased by time. And yet, even gravestones have meaning. They remind the living of mortality. They compel reflection on endurance and fragility. Atlas, in breaking apart, reminded us that even what seems solid is transient. Civilizations like comets may shine for a time, but none are immune to the forces that erode and dismantle. This interpretation is sobering, but it also sharpens the urgency of our search. For if interstellar debris may be gravestones, then humanity must learn to read them, to distinguish natural from artificial, to search not only for signals but for relics. In the dust of a comet, In the fragments of a passing shard, there may be evidence of civilizations erased. Evidence that we are not the first to ask Fermi's question, and perhaps not the last to leave only silence behind. Cosmic gravestones tell us that permanence is an illusion. Planets crumble, stars die, civilizations vanish. What endures are fragments, wandering through eternity. To glimpse one is to be reminded of destiny, not only theirs but ours. For if the galaxy is a graveyard, then Earth is not exempt. One day its fragments too may be cast into the dark, its oceans boiled away by the swelling sun, its continents shattered by cosmic events. Its civilization, if it endures that long, may already have left only ruins behind. Future astronomers, perhaps not human, may see Earth's fragments pass their sky, and wonder, as we do now, who were they, and why did they vanish? In this vision, the Fermi paradox is not a question without answer. It is answered by the gravestones. The silence of the stars is not absence, but testimony, an endless procession of ruins carried between suns. Three-Eye Atlas is one such stone, passing briefly through our sky, a marker of fragility, a reminder of mortality. Its disintegration is a warning. Nothing, not even civilizations, lasts forever. The question hangs over astronomy like a silent weight. Is life rare, or is it common? The discovery of interstellar wanderers, ʻOumuamua, Borisov, Atlas, reshapes how that question is asked. For their very existence proves that planetary systems are not isolated. They are restless, scattering fragments of themselves into the void, contributing to a galactic sea of debris. And if planetary systems are abundant, then the stage for life is everywhere. By conservative estimates, the Milky Way holds 100 to 400 billion stars. Observations from NASA's Kepler mission reveal that planets are not exceptions but norms. Most stars harbour them. Studies suggest that nearly 1 in 5 Sun-like stars may host an Earth-sized planet within its habitable zone, where liquid water could flow. If these numbers hold, then tens of billions of potentially habitable worlds exist in our galaxy alone. This is the statistical foundation of the Fermi paradox. Probability insists that life should be common. Probability insists that civilization should have arisen many times before humanity. Yet the silence of the stars lingers. The arrival of interstellar objects sharpens the dilemma. Their abundance suggests planetary systems are not only numerous, but also dynamic. Each star scatters trillions of fragments during its formation. If even a fraction of these fragments come from worlds that once bore life, then the galaxy may be filled not just with cosmic rubble, but with the wreckage of biospheres. And wreckage, unlike thriving civilizations, is easier to detect. It does not require signals or intention, only survival of fragments, drifting for eons until they pass another star. The distinction between survivors and wreckage is crucial. Civilizations, if they exist, may endure for only thousands or tens of thousands of years, a brief moment in cosmic history. But their remnants, technological or biological, could endure for millions. A probe abandoned in interstellar space may remain intact long after its makers vanish. A fragment of a shattered world may drift for billions of years. A mute record of what once was. Survivors may be rare, ruins may be common. This perspective reframes humanity's search for others. The absence of signals does not imply absence of civilizations. It may simply mean that signals are fleeting, while relics are enduring. Perhaps the true markers of life in the galaxy are not radio waves, but silent storms. Not voices, but fragments. The galaxy may be filled with their remains, and only in the last decade has humanity acquired the tools to begin noticing them. Atlas embodies this idea with unsettling clarity. Its fragile body disintegrated under the sun's heat, leaving only fragments. It was not a survivor, but a ruin. A shard that carried no clear answers, only questions. Its very fragility testified to the violence of cosmic history. And in its ruin, it mirrored the possibility of civilizations themselves. Fragile, impermanent, more likely to leave debris than to endure. But is life itself rare? Here science hesitates, for there is only one known example: Earth. All calculations of probability, abiogenesis, evolution, intelligence, rest on a sample size of 1. To some, this suggests life may be vanishingly rare, an improbable accident never repeated elsewhere. The rare Earth hypothesis argues that Earth's conditions, its stable climate, its protective moon, its magnetic field, its geological activity, may be so unique that complex life is extraordinarily unlikely. If so, then the silence of the stars is no paradox at all. We are alone, and the interstellar debris tells only of lifeless systems. Others reject this pessimism. They argue that life arises wherever conditions allow, that chemistry tends toward biology when given time and stability. Evidence supports this optimism. Organic molecules are common in interstellar space. Amino acids have been found in meteorites. Complex hydrocarbons have been detected in the atmospheres of distant worlds. If the ingredients are everywhere, then life may not be rare. It may be inevitable. If this is true, then the galaxy should not only be filled with planetary fragments, but also with the wreckage of living worlds. Oceans boiled away by stellar flares, atmospheres stripped by radiation, civilizations erased by their own hand. If life flourished widely, then its ruins may vastly outnumber its survivors. And perhaps this is what humanity is beginning to glimpse in interstellar objects. Not living voices, but the silent procession of tombstones. This interpretation casts the galaxy as both abundant and desolate. Abundant in fragments, desolate in voices. The abundance is clear. The statistical avalanche of interstellar debris confirms it. The desolation is inferred. The silence of civilizations demands it. Rare or common? Perhaps life is common, but survival is rare. This duality mirrors Earth's own fragility. Civilization here is young, scarcely a few thousand years old. It exists in a balance as delicate as a comet's orbit, vulnerable to climate, to resource depletion, to the very technologies it creates. If civilizations like ours have risen before, perhaps their ruins now drift unnoticed between stars, indistinguishable from natural debris. Survivors rare, wreckage common. In this light, the search for interstellar objects takes on new meaning. Each one is not just a scientific target, but a philosophical encounter. To study them is to confront the possibility that they are gravestones, fragments of stories ended long ago. They may carry no signal, no language, no deliberate message, but their silence itself may be the message, that survival is the rarest phenomenon of all. Yet there is also hope in their abundance. For if fragments can travel between stars, so too can seeds of life. Panspermia, once speculative, becomes plausible in a galaxy thick with debris. Perhaps interstellar comets carried organic molecules across light years, seeding young worlds with the ingredients for biology. If so, then the ruins of life may also be its conduits, scattering potential beginnings even as they testify to countless endings. Rare or common? The answer may be paradoxical. Life may be common, civilizations rare. Ruins may be common, ʻOumuamua, voices rare. Fragments may be abundant, survivors rare. The galaxy may therefore be filled not with living neighbours, but with silent echoes carried on interstellar stones like Atlas. And so the paradox sharpens. Humanity stands in a galaxy filled with evidence of abundance yet surrounded by fragments. Each new interstellar object confirms that worlds are many. Each one by its science reminds us that civilizations may be few. Three-Eye Atlas becomes more than a comet. It becomes a question. Is life fragile, fleeting, destined to leave only fragments? Or is it resilient, waiting still to reveal its survivors? The universe does not yet answer. It offers only debris. For more than half a century, humanity has aimed its ears toward the stars. Great radio telescopes, Arecibo in Puerto Rico, Green Bank in West Virginia, parks in Australia, have swept their dishes across the heavens, listening for a whisper, a pulse, a pattern that could betray the presence of intelligence. Later, optical instruments joined the search, hunting for laser flashes that might pierce the darkness. Together, these efforts became known as SETI, the search for extraterrestrial intelligence. The logic was straightforward. If civilizations exist, they might do as humans have done, fill their skies with signals. Earth itself has been broadcasting for more than a century. Radio waves from early transmissions, television broadcasts, radar sweeps, all of these leak into space, forming an ever-growing bubble of artificial noise around the planet. If humans broadcast unintentionally, then perhaps others do as well. If they chose to broadcast deliberately, the signals might be even stronger, targeted, meant to be found. The galaxy should not be silent. It should be alive with transmissions, and yet the instruments hear nothing, no beacons, no messages, no deliberate signals. Only the natural hum of pulsars, the static of cosmic background radiation, the ordinary emissions of stars. The vastness of the radio sky is empty of voices. This silence is more profound than absence. It is data. For it forces a narrowing of possibilities. Either civilizations are rare, or they do not last long enough to broadcast. Or they broadcast in ways we cannot detect. Or most unsettling of all, they choose not to broadcast at all. Each possibility deepens the mystery. Meanwhile, interstellar objects, mute fragmenters of rock and ice, prove abundant. ʻOumuamua, Borisov, Atlas. 3 wanderers in as many years remind us that planetary systems fling their debris across the galaxy in staggering numbers. The paradox sharpens. Why is material so plentiful, yet signals so absent? If debris crosses the void with ease, why not voices? Some scientists argue that the problem lies in time. The Drake equation, formulated in 1961, breaks the question into probabilities. The number of stars, the fraction with planets, the fraction of those with habitable conditions, the fraction where life arises, the fraction that achieves intelligence, and the fraction that survives long enough to broadcast. Each factor is uncertain, but the final term, longevity, may be the most decisive. Civilizations may burn bright but brief. Their signals may exist for only 1,000 years, a mere blink in cosmic time. To detect them requires overlap, and the odds of overlap across billions of years are slim. Others suggest that signals are not sent at all. Broadcasting openly into the galaxy may be dangerous. A civilization may fear drawing attention to itself, hiding in silence for survival. The idea is sometimes called the dark forest hypothesis, a galaxy filled with life that chooses to remain quiet, each civilization like a hunter hiding in the shadows, unwilling to reveal its position. If this is true, then the silence of the stars is not emptiness, but caution. But there is another interpretation, one that entwines with the story of Atlas. Perhaps civilizations do broadcast, but they do not endure. Perhaps their messages were sent long ago, but by the time they reach Earth, their makers are already gone. What remains of them are not signals, but ruins. Not voices, but fragments. Their transmissions dissolve into noise, but their debris, comets, asteroids, probes, relics, continues to wander. In this vision, the interstellar objects we see may be the only messages we will ever receive. Messages written not in language, but in silence. This is the unsettling mirror of the Fermi paradox. The galaxy is filled with motion, with debris, with evidence of planetary abundance, but when it comes to voices, it is mute. The silence of signals contrasts with the abundance of stones. Survivors rare, wreckage common. For scientists at SETI, the search continues. New instruments like the Allen Telescope Array, Breakthrough Listen, and next-generation radio arrays expand the hunt to billions of frequencies and thousands of stars. Optical SETI programs search for nanosecond pulses of laser light. Algorithms comb through mountains of data, seeking patterns amid static. And yet, despite the vastness of the effort, the result is the same: silence. Each null detection sharpens the paradox. Each interstellar fragment sharpens it further. For the more abundant planetary systems seem to be, the more puzzling the absence of civilizations becomes. The galaxy appears filled with the ruins of creation, yet empty of voices. This sequence forces reflection. Perhaps communication is not the universal impulse we assume. Perhaps civilizations look outward not to speak, but to survive. Or perhaps their voices are written in forms we cannot yet interpret. The ruins of civilizations may pass within sight, misclassified as comets, dissolving before we can learn their true nature. 3i Atlas, in its fragility, embodies this truth. It broke apart before it could reveal its full story. Perhaps civilizations too break apart, their signals fading before they can be heard. If so, then the silence of signals and the abundance of fragments are two sides of the same truth. The galaxy is not empty, it is fragile, and so the question lingers. Is this all humanity will ever receive? Not voices, not deliberate messages, but shards, mute, ambiguous, and unrecognizable. If so, then the universe speaks not in transmissions, but in ruins. The silence of signals is not absence. It is testimony, written in fragments of stone. In this silence lies a profound lesson. The galaxy is filled with matter, yet bereft of voices. And perhaps in the end, the fragments themselves are the only messages that endure, tombstones drifting between the stars. The Fermi paradox asks a question that should not be so difficult to answer. If civilizations are probable, if stars are plentiful, and if time is vast, then where is everyone? The night sky should be filled with voices, yet the silence persists, heavy, absolute and unbroken. One interpretation is hopeful, perhaps humanity is early, the first flicker of awareness in a galaxy that has not yet awakened. Another is bleak. Perhaps civilizations are common, but their lifetimes are short. They burn bright, but they burn out. And what remains of them are not voices, but ruins, debris scattered through interstellar space like the ashes of forgotten fires. This is the dark interpretation of the paradox, that the galaxy is not empty, but haunted. Haunted not by living neighbours, but by the relics of those who came before. Astronomers already know that destruction is common. Stars collapse into supernovae, releasing more energy in a second than the sun will emit in its lifetime. Planets wander into unstable orbits, colliding with each other in apocalyptic violence. Radiation bursts sweep across light years, sterilizing worlds. Entire systems can be reshaped or erased by forces blind to the lives they extinguish, and civilizations add to their own peril. The tools that allow intelligence to flourish, energy, technology, control of nature, can also hasten its collapse. On Earth, nuclear fire, climate change, engineered plagues, and artificial intelligences stand as shadows over the future. Each is a reminder that intelligence does not guarantee survival. It magnifies power, but also vulnerability. In this view, interstellar objects take on a chilling significance. ʻOumuamua, Borisov, Atlas, mere fragments of other systems, may not only be natural debris, they could represent what survival leaves behind, flotsam of civilizations that burn too brightly, too briefly, reduced to ruins before their voices could echo across the stars. If even one such object were a relic, then the paradox would be answered not by silence, but by mortality. The dark interpretation sees the galaxy as a graveyard. Civilizations rise and fall like comets passing near the sun. Their signals are short-lived, their lifetimes fragile. They vanish before their messages cross the gulf to other stars. Their ruins, however, endure, silent, drifting, stripped of meaning yet undeniable in their presence. Survivors may be rare, debris plentiful. This perspective is not only speculation, there are precedents in what telescopes already observe. Around white dwarfs, the burned-out remnants of stars, astronomers have detected rings of debris, the shattered remains of once-living planets. These are planetary gravestones, visible evidence that destruction follows creation. If planets themselves can be ground to dust, what hope for civilizations built upon them? The dark interpretation also confronts the unsettling possibility that intelligence itself may be self-limiting. Each species that reaches the power to shape its world may eventually destroy it. If so, then the silence of SETI is not puzzling, it is inevitable. Civilizations are there, but only briefly. Their voices end before their echoes can be heard. What endures is their flotsam, fragments drifting endlessly like Atlas, mute, broken, and unrecognized. And so, perhaps humanity already stands amid ruins. The interstellar objects passing through the solar system may be the remnants of civilizations erased long before Earth even formed. They are not signals to be decoded, but ashes to be noticed. The paradox is not an absence of life, it is the presence of its wreckage. Such an interpretation is sobering, but it carries a kind of clarity. It reframes the search. Instead of expecting messages, perhaps humanity must learn to look for remnants, chemical anomalies in interstellar debris, isotopic ratios that betray artificial processes, fragments that do not behave like comets or asteroids. The search for life may be less about conversation, more about archaeology. A cosmic archaeology where the ruins are scattered across light years, drifting in silence. The dark interpretation also turns the gaze inward. If civilizations fall quickly, what of Earth? Humanity is young, scarcely a blink in cosmic time. The threats that loom over the future may not be abstract, they may be universal. Atlas, disintegrating before it could be fully studied, becomes a symbol of impermanence. Like a comet undone by sunlight, civilizations may unravel when the pressures become too great. The ashes they leave may be all that remains. Still, there is a paradox within the paradox. If ruins are everywhere, why are none unmistakable? Why no fragments of unmistakably artificial design? Why no objects glimmering with metal alloys, or etched with patterns, or broadcasting faint ancient beacons? Perhaps the answer lies in entropy. Time erodes not only civilizations, but their technologies. Metals corrode, signals fade, structures collapse. After millions of years in interstellar space, even the most advanced machines may be indistinguishable from stone. Ruins dissolve into rubble. Messengers dissolve into silence. Thus the paradox becomes darker still. Not only do civilizations die, but their evidence does too. What remains is ambiguous. Stones that may be stones, or may be relics. Comets that may be natural, or may be tombstones. Humanity stands in the midst of ruins, but cannot yet tell which are natural and which are not. This is the unsettling beauty of the dark interpretation. It replaces emptiness with tragedy. The galaxy is not devoid of life. It is full of endings. The silence is not the silence of absence, but of aftermath, and so the wanderers, ʻOumuamua, Borisov, Atlas, become more than curiosities. They become emblems of mortality. They remind humanity that civilizations may not be measured in their broadcasts, but in their debris. That survival may not be the norm, but the exception. And that the question, where is everybody, may already have its answer. They are done, and this is all that remains. The dark interpretation does not promise comfort, but it does promise truth of a kind. It warns that the ruins of others may already be before us, disguised as fragments of stone. It suggests that the galaxy's silence is not ignorance but memory, a memory written in rubble, drifting endlessly between stars. The cosmos does not always require the hand of intelligence to create its mysteries. For every whisper of speculation about civilizations and ruins, there are explanations grounded in the quiet mechanics of nature, processes that, though blind, can sculpt wonders no less profound. Interstellar objects like ʻOumuamua, Borisov, and Atlas may not be relics of alien minds, but the inevitable byproducts of planetary birth and cosmic evolution. In the early lives of stars, chaos reigns. Around each newborn sun, a swirling protoplanetary disk takes shape, dense with gas, dust, and icy fragments. Gravity, like an unseen sculptor, begins its patient work. Particles collide, sticking together, growing larger. Pebbles become boulders, boulders become planetesimals. Over millions of years, some of these planetesimals grow into planets. Others never achieve stability. They are captured, broken, or ejected. This is the first and most natural explanation for interstellar wanderers. They are exiles from the violent childhoods of stars. When massive planets form, giants like Jupiter or Neptune, their immense gravity can fling smaller bodies outward, accelerating them to escape velocity. Once freed, they wander the galaxy stripped of origin, bound only by momentum. Simulations of planetary formation support this view. In nearly every model, the process of building stable planetary systems produces staggering amounts of debris. For every planet that remains, countless fragments are ejected into interstellar space. If the Milky Way holds hundreds of billions of stars, and each star sheds trillions of fragments during its youth, then the galaxy becomes not a void, but a river of wandering objects. This alone could explain the abundance of interstellar visitors without invoking civilizations. ʻOumuamua, in this interpretation, might simply be one such fragment, a shard of rock or ice expelled from its parent star millions or billions of years ago. Its unusual shape and acceleration could be attributed to natural processes. Some models suggest that hydrogen icebergs could form in the cold nurseries of giant molecular clouds. If such a body were ejected and travelled through space, its sublimation would be nearly invisible, yet still sufficient to explain the faint acceleration ʻOumuamua displayed. Others propose that it may have been a fragment of nitrogen ice, chipped from the surface of a Pluto-like world during a collision. Over time, erosion by cosmic rays could have sculpted its extreme geometry, leaving it elongated or flattened in ways rare within the solar system. In this light, ʻOumuamua's strangeness is not proof of alien design, but a reminder that the galaxy is older and more diverse than human expectations. Billions of years of cosmic erosion can produce forms never seen in our local neighbourhood. It is not that ʻOumuamua was unnatural, but that it was unfamiliar, an emissary from a context we have never directly witnessed. Borisov too fits naturally into this framework. Its coma and tail marked it clearly as a comet, rich in ices that evaporated under the sun's heat. Spectroscopy revealed cyanide gas, carbon monoxide and dust, substances familiar from comets within our own solar system. The conclusion was striking not for its mystery, but for its ordinariness. Comets form under the same rules everywhere. Chemistry is universal. The elements that build planets, that build life, are not rare. They are scattered throughout the galaxy, obeying the same laws under alien suns. Atlas added another piece to the natural story. Its fragility, its disintegration under solar heat, revealed that interstellar wanderers need not be sturdy, and so many may arrive weakened by cosmic rays, fractured by internal stresses, ready to crumble at the first encounter with a star. This fragility suggests that much of the galaxy's debris may never be seen at all, breaking apart before discovery, reduced to dust invisible to our instruments. These natural explanations carry their own quiet awe. They remind humanity that the galaxy is not empty, but filled with processes that echo across billions of years. Every fragment is testimony to the universality of physics: gravity pulling, collision shattering, radiation eroding, chemistry repeating. The abundance of interstellar objects becomes a predictable consequence of cosmic evolution. And yet, even as these theories explain, they deepen the mystery. For if planetary systems are so common, if debris is so abundant, if the ingredients of comets and asteroids are universal, then why not life? The natural explanations account for the fragments, but they sharpen the paradox of the silence. The more ordinary ʻOumuamua and Borisov appear, the more extraordinary the absence of civilizations becomes. Perhaps this is the hidden tension of the alternative theories. They explain the presence of stones, but not the absence of voices. They show that the building blocks are everywhere, that the processes are universal, that the galaxy is rich with potential. But in doing so, they force a darker reflection. If the galaxy is fertile, then perhaps intelligence does not flourish, or does not endure. There is also humility in this perspective. For centuries, humans assumed the solar system was unique, Earth special, life rare. Each new discovery has chipped away at that belief. Exoplanets are common. Comets and asteroids are universal. Interstellar fragments flow constantly through the galaxy. What once seemed rare is revealed to be ordinary. And so perhaps, dear, the silence of civilizations is the final inversion. What once seemed inevitable may, in truth, be rare. Alternative theories ground the discussion in nature, in physics and chemistry rather than speculation. They remind us that extraordinary claims require extraordinary evidence. ʻOumuamua need not be a probe. Atlas need not be a tombstone. They may simply be what the galaxy produces in abundance. Debris scattered by the restless lives of stars. And yet, even when grounded in natural explanation, the mystery does not vanish. It only shifts, for the silence of the stars remains. The interstellar fragments are real, measurable, undeniable. They tell us that the galaxy is filled with planetary systems. They tell us that the ingredients of life are everywhere. They tell us that matter crosses the gulf between stars with ease, and still no voices. The natural interpretations of interstellar objects are powerful, elegant, and convincing. But they do not resolve the paradox, they amplify it. The debris explains abundance. The silence explains fragility, and together they weave a haunting vision of a galaxy alive with matter, yet quiet in mind. Perhaps the truth lies in both visions at once. The galaxy is filled with natural debris, but among it may drift the rare relic of intelligence. The overwhelming majority of ʻOumuamuas and Borisovs may be natural, but even one fragment that is not would change everything. Until that evidence comes, science leans toward the ordinary. The interstellar objects are ejected comets, byproducts of planetary birth, natural children of cosmic evolution. And yet, as each fragment passes, the deeper question persists, not about what they are, but about what they imply. For if the galaxy is so fertile, if the debris is so abundant, then the silence of civilizations becomes not less mysterious, but more. For most of human history, the sky was a mystery unbroken by detail. Stars burned as steady points, planets wandered slowly, comets appeared suddenly and vanished again. Only in the last few centuries have instruments extended human vision beyond the limits of the eye. And only in the last few decades have they grown sharp enough to glimpse the faintest, fastest wanderers, objects like ʻOumuamua, Borisov, and Atlas. The discovery of interstellar objects was not a coincidence. It was the result of machines built with purpose, telescopes designed to watch the sky not for beauty, but for change. Chief among them is the Asteroid Terrestrial Impact Last Alert System, or ATLAS. On the volcanic slopes of Hawaii, ATLAS scans the heavens each night, searching for anything that moves. Its mission is planetary defense, to spot asteroids that might one day collide with Earth. But in fulfilling this duty, it has also revealed more. In 2019, ATLAS detected the faint trace of a comet that would later be named 3 Eyes Atlas, the third known interstellar object. A machine built to protect Earth instead glimpsed a messenger from another star. Beside ATLAS stands another sentinel, Pan-STARRS, the Panoramic Survey Telescope and Rapid Response System. Also in Hawaii, its wide-field cameras sweep the sky with extraordinary sensitivity. It was Pan-STARRS that first noticed ʻOumuamua in October of 2017. Without it, the first interstellar visitor might have passed unnoticed, lost to darkness. Pan-STARRS was built to guard against near-Earth threats, but it uncovered something larger. The truth that the solar system is not isolated, that fragments of other worlds pass through routinely. These instruments are not alone. Across the globe, networks of telescopes, both professional and amateur, turn their mirrors toward the heavens, catching faint trails of light. Once discovered, objects like Borisov are tracked by observatories worldwide, each instrument adding pieces to the puzzle. The discoveries of the last decade are the fruit of a planetary collaboration, a web of vigilance stretched across Earth. But even these eyes are limited. ʻOumuamua was discovered only after it had already passed its closest approach to the Sun, already speeding away. ATLAS was detected only weeks before it began to disintegrate. Each discovery has been fleeting, leaving scientists desperate for more time, more data, more clarity. The need is clear: deeper surveys, faster response, sharper instruments. The next great leap will come from the Vera C. Rubin Observatory, rising now in the thin air of northern Chile. Scheduled to begin its survey within this decade, Rubin represents a revolution in astronomy. Its 8.4-metre mirror, coupled with a camera the size of a small car, will scan the entire visible sky every few nights. Its database will track tens of billions of stars, galaxies, asteroids and comets, every flicker, every motion, every anomaly. Among them, hidden like needles in a cosmic haystack, will be interstellar objects. Rubin's sensitivity is such that it may detect dozens, perhaps hundreds, of these wanderers in its first decade of operation. No longer will interstellar visitors be rare accidents of discovery. They will become a class of objects, studied systematically, catalogued as part of the ordinary traffic of the galaxy. What might these tools reveal? Each detection will add to the statistical picture, sharpening estimates of how many fragments drift through the Milky Way. Some may resemble Borisov, rich in ices, confirming that cometary chemistry is universal. Others may echo ʻOumuamua, enigmatic in shape and motion, challenging categories and inviting speculation. Some may crumble like ATLAS, teaching us about fragility and impermanence, and perhaps among them one may defy natural explanation altogether. To prepare for that possibility, new missions are already being proposed. Concepts exist for rapid response spacecraft, designed to launch at short notice, intercepting interstellar visitors before they vanish. To touch such an object, to sample its surface, would be to hold in human hands a fragment of another star system. It would be a direct encounter with material forged under alien suns, a piece of the galaxy delivered to our doorstep. These tools of detection are more than instruments of science. They are extensions of human perception, new senses stretching into the dark. Through them, humanity learns that the universe is not still, but alive with motion. The wanderers are countless, and the machines are finally sensitive enough to see them. But the deeper question remains: what will they reveal? If most interstellar objects prove ordinary, then the galaxy will be shown as fertile but silent. If even one proves extraordinary, bearing isotopes that cannot be natural, structures that cannot be explained, then the silence of the stars will be broken, not by signals, but by relics. The paradox would be answered not by voices, but by debris. The decades ahead promise both abundance and ambiguity. Rubin will open a floodgate of data, overwhelming in its scope. ATLAS and Pan-STARRS will continue their vigilance, scanning for near-Earth threats while revealing messengers from afar. New instruments in space may one day join them, free from the distortions of atmosphere, peering deeper into the night. Together, they will transform our understanding of interstellar objects from rarity to routine. And yet, even as detection becomes easier, interpretation may not. Each new fragment will pose the same question: is this natural, or is this a ruin? Is this cosmic debris, or a silent messenger? The tools will give us eyes, but they may not give us certainty. Still, the pursuit is essential, for the alternative is blindness, a return to a time when wanderers passed unnoticed, when the galaxy's messages were invisible. The tools of detection are humanity's way of refusing that blindness, of insisting that the universe be seen, measured, and understood. Through Atlas, Pan-STARRS, and soon Rubin, humanity steps into a new relationship with the stars. The sky is no longer a backdrop, but a dynamic system filled with travelers. Each detection is a reminder that the solar system is not isolated, that the galaxy is restless, and that in its restlessness may lie the answers to the oldest question of all. What else may these tools reveal in the decades to come? Perhaps only fragments of stone and ice, silent in their passing. Or perhaps, hidden among the ordinary, a single object that is not what it seems. A tombstone, a relic, a messenger, a fragment that rewrites the silence into meaning. The machines are watching, the sky is waiting, and the wanderers are already on their way. The interstellar visitors slip past quickly, ghosts crossing the solar system, lingering only weeks or months before vanishing back into the void. ʻOumuamua was discovered after it had already made its closest approach to the sun. By the time its significance was realized, it was already too distant, too fast to pursue. Borisov was more generous, its bright cometary tail visible for longer, but even it faded quickly, gone in a matter of months. An atlas disintegrated before it could be studied in detail, scattering itself into fragments that dissolved into invisibility. The brevity of these encounters has left astronomers with a longing, not merely to observe interstellar objects, but to reach them, to touch them, to study them up close. To hold in human instruments a fragment of another star system is a dream at the very edge of possibility, but to achieve it requires more than wonder. It requires preparation. The challenge lies in speed. Interstellar objects travel at tens of kilometers per second, moving too fast for conventional spacecraft to catch once they are already inbound. By the time they are discovered, it is often too late. To intercept one, humanity must either be ready to launch with little notice, or send out probes already waiting, stationed like sentinels at the edge of the solar system. Scientists have begun to imagine such missions. One concept, called Project Lyra, envisions a spacecraft propelled by powerful rockets, gravitational assists, or even solar sails, racing to pursue an object like ʻOumuamua. Another idea involves pre-positioned interceptors, dormant in orbit until awakened by the discovery of a passing wanderer. More ambitious still are proposals to place probes beyond the planets, where then they might one day cross paths with an interstellar traveller naturally. The Vera Rubin Observatory, soon to begin its deep survey of the night sky, will change the odds. By detecting these objects earlier, months, perhaps even years before they approach, Rubin may give humanity the lead time required to launch a pursuit. The dream is to send a spacecraft capable of rendezvous, not just flyby, to slow, to match velocities, to linger alongside a fragment from another star, studying its surface, its chemistry, its secrets. What might be learned from such an encounter? The possibilities are staggering. By sampling the material of an interstellar object, scientists could compare directly the chemistry of other planetary systems with that of our own. Do comets elsewhere contain the same ices, the same organics, the same building blocks of life? Or do they differ, carrying exotic molecules never seen before? Such answers would speak to the universality of life's potential, to whether biology is a common outcome of chemistry or a rare accident of Earth. Even more tantalizing is the possibility that among the countless natural fragments, one might carry something artificial, evidence of technology, however ancient, however eroded. To intercept such an object would be to touch a relic of civilization, to find in the silence of the stars a whisper written in matter rather than in sound. It would be the first direct evidence that humanity is not alone. But even if every object proves natural, the pursuit is no less profound, for each fragment is a time capsule, carrying the history of a distant system across millions of years. Its isotopes, its minerals, its organic compounds, all are records of environments humanity cannot yet visit. To hold them is to hold pieces of alien worlds, to study the geology of systems light years away without leaving the solar system. The expanding hunt, then, is more than a scientific program. It is a philosophical turning point. Humanity is no longer content to watch from afar. It wishes to reach, to grasp, to close the distance between imagination and evidence. To touch an interstellar relic is to bridge the gulf between stars in the most intimate way possible. Not with communication, not with colonization, but with contact. The dream is vast, but it is not impossible. Technology already exists in pieces. Solar sails could provide the acceleration. Nuclear propulsion could supply the energy. Gravitational assists from planets could slingshot probes onto interstellar trajectories. What is required is not invention, but will. The choice to prepare, to pursue, to make the fleeting encounters of interstellar visitors into lasting opportunities. There is urgency in this dream. The visitors do not wait. They come without warning, and they go without return. Each one carries knowledge that once lost cannot be regained. ʻOumuamua will never pass this way again. Borisov is gone forever. Atlas is dust. The next may already be inbound, unseen in the dark. To be ready is to honour the rarity of these moments, to refuse to let the galaxy's messages slip past unnoticed. The hunt is expanding not only in telescopes that watch, but in missions that prepare. Humanity stands at the threshold of becoming not just an observer of interstellar wanderers, but a participant in their story. Each passing fragment offers a question. To pursue one is to demand an answer, and perhaps one day the answer will not only speak of chemistry, but of civilization. Perhaps the relic humanity touches will not be stone, but something more. Until then, the expanding hunt is an act of faith, that the universe has messages to give, and that humanity must be ready to receive them. The next messenger is already on its way. Somewhere in the dark between stars, a fragment drifts closer, unseen. Whether it is dust, ice, rock, or ruin, it will pass through as others have. The question is whether we will be ready to meet it, or whether, like those before, it will vanish into silence, leaving only longing in its wake. The hunt expands because the silence endures, and because in that silence, humanity cannot help but listen harder, reach further, and prepare for the day when a fragment from the stars does not slip away, but is touched, studied, and finally understood. In the silence of the stars, speculation becomes a kind of mirror. Natural explanations for interstellar objects are compelling, elegant, and grounded in physics. Yet one possibility lingers at the edge of imagination. What if even one of these wanderers is not natural at all? What if among the countless fragments of rock and ice, there drifts a machine, an artifact of a civilization long vanished, disguised in the form of stone? This is the alien technology hypothesis. It suggests that civilizations may seed the galaxy not with fragile radio signals, but with durable machines. Objects that, unlike broadcasts, do not fade with distance or dissolve into static. Machines can endure. Machines can persist. While voices may vanish in centuries, an artifact can drift for millions of years, awaiting discovery. The idea is not fantasy, but an extrapolation of human intent. Already, Earth has sent probes into interstellar space. Voyager 1 and Voyager 2, launched in the 1970s, carry golden records, messages etched into metal, intended for whoever might one day find them. Pioneer 10 and 11 carry plaques inscribed with diagrams of humanity's place in the cosmos. These machines are primitive by future standards, yet they will outlast their makers. Long after Earth is unrecognizable, they will still drift through the galaxy, silent witnesses to a civilization that once was. If humanity, in its infancy, has already seeded the stars with relics, then what might civilizations millions of years older have accomplished? Perhaps they sent probes not merely as symbols, but as explorers, machines that replicate themselves, spreading exponentially, disguised among the comets and asteroids of alien systems. Theoretical physicist John von Neumann first proposed the concept of self-replicating probes, machines that could mine resources from the objects they encounter, copying themselves endlessly, colonizing the galaxy not with biology, but with machinery. If such devices were ever built, they would not need to transmit signals. They would become the signals, the messengers written in matter. In this vision, the galaxy is not silent, but seeded. seeded not with voices but with artifacts. The interstellar objects that slip through the solar system could, in principle, be such machines. If designed to blend with natural debris, they would appear indistinguishable from comets or asteroids until studied closely. Their silence would not be absence, but camouflage. ʻOumuamua sharpened this speculation. Its peculiar acceleration, its extreme shape, its lack of cometary tail, all invited questions. Could it be a light sail propelled by starlight? Avi Loeb argued that it might. A thin structure, reflecting sunlight, could explain its motion without jets of gas. If true, it would not be natural, it would be a machine. Most astronomers resisted the claim, pointing to exotic natural explanations, yet the possibility was enough to ignite debate, to remind humanity that the line between debris and artifact is thin and often invisible at a distance. The alien technology hypothesis also offers an unsettling reinterpretation of the Fermi paradox. If civilizations exist, why no signals? Perhaps because signals are fragile. They scatter, viscous, fade and vanish in time, but probes, machines, can persist. If civilizations chose to send artifacts instead of broadcasts, then the galaxy may be filled with them already. Humanity may simply not have recognized them yet. This possibility transforms how the search is imagined. SETI has long focused on radio telescopes, scanning for signals, but perhaps the search should also be archaeological, studying interstellar objects, scanning them for anomalies, analysing their composition for signatures not found in nature. Even fragments, broken or eroded, could bear evidence of manufacture. Unusual alloys, geometric structures, isotopic ratios impossible to explain by natural processes. The hypothesis does not demand that all interstellar objects are artificial, only one. If even one of the trillions drifting between stars were revealed to be a machine, history would change forever. The proof of another civilization would be undeniable, written not in speculation but in substance. The silence of the stars would no longer be absence but evidence of mortality. For if such a probe were ancient, drifting without signal, it would suggest that its makers were gone, leaving only artifacts behind. This is where the alien technology hypothesis intersects with the darker interpretations of the paradox. Perhaps civilizations seed the galaxy with machines, but they do not endure, their voices fade. Their worlds fall silent, yet their artifacts remain, mute tombstones wandering among the stars. The relics survive their creators, as Voyager will survive humanity. And so the galaxy may be filled not with thriving civilizations, but with ruins disguised as stones. The possibility also reframes the meaning of interstellar contact. Humanity often imagines a dialogue, messages exchanged, signals deciphered, conversations across the gulf. But what if the first contact is not with voices, but with silence? Not with a living species, but with its remains. To encounter a probe disguised as rock would be to encounter not neighbours, but ancestors. A civilization long dead, leaving only its machines as epitaphs. And yet, even in such silence, there is connection. For to touch a relic is to know that others once lived, thought, and built. It would mean humanity is not unique, not alone, not the first to wonder at the stars. The alien technology hypothesis, however speculative, is also profoundly hopeful. It suggests that civilizations leave traces, that even if they do not endure, they do not vanish without a mark. To test this hypothesis requires patience and vision. Future telescopes may reveal anomalies in interstellar objects. Future probes may intercept one, analysing it closely, perhaps even bringing samples back to Earth. If such a fragment is natural, it will teach us about alien systems. If it is artificial, it will teach us about alien minds. Both outcomes are extraordinary. The alien technology hypothesis remains unproven, controversial, and for many unlikely. But its power lies not in certainty but in possibility, for it widens the horizon of imagination. It reminds humanity that the universe may speak in ways not yet understood, that the silence of signals may not mean emptiness, but a different kind of message, written not in light, but in matter. And so the interstellar wanderers drift on. Stones in the dark, fragments of worlds, perhaps relics of civilizations. Each one is a question, natural or artificial, debris or messenger, tombstone or probe. The alien technology hypothesis does not answer. It only deepens the mystery. But in that deepening lies a truth, that to search the stars is to search not only for others, but for the traces they may have left behind. The silence of the galaxy may not be an accident. It may be a filter, a barrier that few civilizations pass, no matter how promising their beginnings. A filter that explains why the stars remain quiet, why no signals arrive, and why the only visitors humanity sees are fragments of stone and ice, mute, indifferent, and ancient. This idea is often called the Great Filter. It asks, if the universe is fertile, if planets are countless, and if the chemistry of life is universal, then why has no civilization revealed itself? The answer, perhaps, is that the path from chemistry to culture is littered with failures. At some stage, whether before life begins, before intelligence emerges, or after civilizations rise, most do not survive. The filter could lie in the distant past. Perhaps the leap from non-living chemistry to biology is far rarer than imagined. If so, Earth is an extraordinary outlier, the improbable exception in a galaxy otherwise sterile. In this case, the silence is not tragic but inevitable. There are no others because life itself is vanishingly rare. But the filter could also lie ahead, and this is the darker possibility. Perhaps civilizations arise frequently, but their lifespans are short. They collapse under the weight of their own technologies, their own desires, their own mistakes. Nuclear fire, climate catastrophe, engineered pandemics, or artificial intelligences may end them before they spread to the stars. In this vision, the silence of the galaxy is not emptiness, but aftermath. Civilizations bloom briefly, then vanish, leaving only debris behind. Here the wanderers, ʻOumuamua, Borisov, Atlas, take on a symbolic role. They are not just fragments of planetary systems, they become metaphors for fragility. Atlas in particular, crumbling under the pressure of sunlight, embodies impermanence. What endured for millions of years unraveled in weeks. If civilizations are like comets, then the galaxy is filled with their ruins, scattered, fragmented, mute. The Great Filter thus explains the paradox not by denying abundance, but by emphasizing mortality. Civilizations exist, but they do not endure long enough to fill the galaxy with signals or colonies. What survives of them may be only fragments, probes without makers, ruins disguised as stones, relics indistinguishable from comets. The interstellar debris humanity sees could be more than natural. It could be the archaeological record of failure, drifting silently between stars. The filter idea is unsettling precisely because it includes Earth. If civilizations rarely survive, then humanity's own future is uncertain. The technologies that empower it, nuclear arsenals, genetic engineering, artificial intelligence, are double-edged. Each holds promise, but also peril. The very traits that allow a species to control its environment may also guarantee its destruction. The galaxy's silence becomes a warning, written not in words but in absence. And yet, even in this bleak possibility, there is nuance. If civilizations collapse, they may still leave traces. The Voyager probes will outlast humanity, drifting for billions of years. Ruins on the Moon and Mars may persist long after Earth itself is gone. In this sense, fragments like Atlas may indeed be the filter embodied, evidence of systems that flourished once, then fractured, leaving only debris to wander the void. Survivors are rare, ruins abundant. Some see hope in this. If the Great Filter lies behind humanity, if the improbable leap from chemistry to consciousness has already been passed, then survival may yet be possible. The silence of the galaxy would mean not that doom awaits, but that life itself is rare and Earth extraordinary. But if the filter lies ahead, then humanity is unprepared, standing on the edge of dangers it has not yet mastered. The interstellar objects sharpen this dilemma. They prove that planetary systems scatter their fragments widely. If civilizations scatter themselves in similar ways, then traces should be everywhere. The absence of unmistakable artifacts suggests that either civilizations are vanishingly rare, or that they fall before spreading. Either answer casts the wanderers in a new light. They are the stones of a vast cosmic cemetery, drifting through the galaxy as mute testimony to impermanence. To confront the Great Filter is to confront mortality on a cosmic scale. It forces reflection not only on what civilizations might become, but on what they fail to be. It reminds humanity that survival is not inevitable, that progress is not guaranteed, that fragility is written into the fabric of existence. Atlas, crumbling under sunlight door, becomes more than a comet. It becomes a parable, and so the silence of the stars may not be absence at all. It may be warning. The galaxy is not empty. It is full of gravestones. The great filter ensures that voices are brief but ruins endure. Civilizations rise, collapse and vanish, leaving behind only fragments that wander between stars. Humanity, in glimpsing them, may be glimpsing its own possible future. The great filter remains theory, but its shadow stretches across the night sky. It urges humility, vigilance and reflection. For if the silence is not emptiness, but aftermath, then survival itself becomes the rarest phenomenon in the universe. In the fragments, in the wanderers, in the silence itself, the message may already be written. Few endure. Every fragment that drifts into the solar system carries with it a story written in matter. Its surface is scarred by collisions, its chemistry shaped by the star that once warmed it, its fractures etched by the violence of ejection. These silent wanderers are not only debris, they are records. To study them is to practice a science unlike any other, cosmic archaeology where the artifacts are not buried in soil, but adrift in the interstellar dark. On Earth, archaeologists sift through shards of pottery, ruins of stone and fragments of bone to reconstruct cultures long gone. Each fragment, however small, is a clue. The same principle applies to interstellar objects. By examining their isotopes, their minerals, their organics, scientists can reconstruct the histories of distant worlds. The question is not whether these objects can speak, but how to learn to read their language. Already hints have been revealed. The interstellar comet Borisov displayed cyanide and carbon monoxide in unusual concentrations, evidence that the chemistry of comets is not unique to our solar system. Its dust grains resembled those of local comets, but in their abundance of carbon, they suggested subtle differences, a signature of an alien nursery cloud. In Borisov's tale, humanity glimpsed the chemistry of a world never seen, a planet-forming disk under another star. ʻOumuamua told a different story. Its lack of visible ices, its strange acceleration, and its extreme shape suggested a fragment weathered by deep time. Perhaps it was once part of a Pluto-like world sheared off in a collision, sculpted by cosmic rays and sent adrift. If so, it carried within it the record of an ancient surface frozen far from its star, preserved for eons before drifting through ours. Atlas revealed fragility. Its disintegration under solar heat suggested a body loosely bound, weakened by the long exposure to radiation. It was not built to endure, but to crumble. Even in its death it spoke, of systems where comets are fragile, of conditions that differ from our own, of impermanence as a universal law. Each of these fragments is a shard of cosmic history. None are whole, none tell the full story. But together they form a mosaic, a growing archive of alien systems. With every interstellar object detected, the archive grows richer, the picture sharper. Cosmic archaeology transforms the galaxy into a field site where the ruins are not cities but stones drifting between stars. Future science will expand this excavation. Telescopes will not only track interstellar objects, but analyze their spectra in detail, reading their light to determine their composition. Spacecraft may one day intercept them, drilling into their surfaces, collecting samples, returning fragments to Earth. Each grain of dust would be a relic, a piece of another world studied under microscopes, its isotopes revealing the fingerprint of the star that birthed it. This kind of archaeology does not search for voices. It searches for chemistry. It asks not what civilization said, but what worlds were made of. It looks for the universality of organics, the spread of water, the presence of complex molecules. It asks, are the ingredients of life rare, or are they written into the fabric of the galaxy? And yet cosmic archaeology does not exclude the possibility of civilizations, for if fragments can carry natural chemistry, they may also carry traces of the artificial. A shard of alloy instead of stone, a structure patterned, not random, an isotope ratio impossible in nature. To find such a relic would be to uncover not just a fragment of a world, but a fragment of a culture. The search for extraterrestrial intelligence may not be through signals at all, but through excavation of the galaxy's drifting ruins. This vision reframes the silence of the stars. Perhaps we will never receive a transmission. Perhaps civilizations do not endure long enough to speak across light years, but their fragments may endure, scattered across space waiting to be uncovered. The galaxy may be filled not with conversations, but with ruins, mute, but not meaningless. Archaeology, not dialogue, may become the science of contact. The work has only begun. With each new interstellar object discovered, astronomers refine their tools, learning to catch faint streaks of light against the stars to analyze their fleeting brightness, to extract meaning from their brief appearance. The more we discover, the better we learn to read the language of fragments. In this, cosmic archaeology becomes not just a science, but a philosophy. It teaches that absence of voices does not mean absence of stories. It reminds us that silence is not emptiness, but an invitation to look deeper. Every fragment is a message written in matter, waiting for eyes sharp enough to see. One day, the excavation may reveal more than chemistry. One day, a fragment may bear evidence of intention. If that day comes, the silence of the stars will end not in sound, but in substance. Humanity will not have spoken to another civilization, but uncovered its remains. Until then, the galaxy is a field of ruins, scattered invisibly across the dark. Each interstellar object is a shard of that great ruin, drifting past like pottery fragments on the floor of an ancient ocean. To study them is to become archaeologists of the cosmos, piecing together a history larger than Earth, larger than humanity, larger than time itself. And so the work continues. The fragments pass, the instruments watch. And in their silence, the universe offers itself not as a void, but as a story waiting to be unearthed. The discoveries of ʻOumuamua, Borisov, and Atlas began as scientific revelations, but their meaning stretches far beyond astronomy. For hidden in their silence is a mirror, a reminder that what we see drifting past may not only be fragments of alien systems, but a vision of our own eventual fate. The thought carries weight. If the galaxy is filled with ruins, if fragments are more common than voices, then what does it say about humanity? Is it destined to leave behind only shards? A few probes drifting forever? A scattering of dust after oceans have boiled away? A faint chemical trace preserved in stone? Will Earth one day vanish, leaving only relics to wander among the stars? Such questions are not purely speculative. Already humanity has seeded the cosmos with its first artifacts. The Voyagers drift beyond the heliosphere, carrying golden records etched with greetings and music. Their makers already generations gone by the time another star is reached. The pioneers, with their plaques, drift along different paths. Even the discarded upper stages of rockets, flung outward by the momentum of exploration, may one day leave the solar system entirely. These are the first whispers of Earth's presence beyond its own star. But they are fragile as Atlas. Their circuits will decay, their inscriptions will fade. In a million years they may be unrecognizable, indistinguishable from natural debris. And this is the emotional core of the paradox. For the silence of the stars may not be absence at all, but testimony. Testimony that civilizations do not last forever, that even in triumph their voices are brief. What remains of them are not dialogues, but tombstones, and humanity, for all its brilliance, may be no different. The weight of this realization is not despair alone, it is also humility. It reminds us that survival is not guaranteed, that civilization is fragile, that the forces which unmade Atlas can find their reflection in the forces which might one day unmake us. Climate instability, nuclear fire, self-made technologies, all are the sunlight that could fracture us, scattering us into silence. And yet, fragility is not only burden, it is also poignancy. The knowledge that we may not endure forever imbues the present with meaning. Each transmission, each work of art, each fragment of culture becomes precious in the face of impermanence. Just as archaeologists treasure broken shards of pottery because they are all that remain of lives once lived, so too might our fragments, scattered into interstellar space, be treasured by distant eyes in some unimaginable future. If Earth is destined to leave only ruins, then those ruins will still speak. They will say, "We lived." They will say, "We wondered." They will say, "We looked outward, even as we were fragile." The cometary shards that drift from our solar system into the galaxy will carry with them the chemical fingerprints of our oceans, our rocks, our skies. The machines we build and send into the void will carry with them symbols of our thought, however faded. Even after humanity is gone, the galaxy will know that here, once, a civilization existed. There is an emotional gravity to imagining the future of Earth in this way. the sun itself will one day swell into a red giant, boiling the oceans, stripping the atmosphere, rendering Earth uninhabitable. Long before that, humanity may be gone, undone by its own fragility or by cosmic forces indifferent to its survival. The question is not whether Earth will endure, it will not, but whether something of its story will survive the collapse. The interstellar objects remind us that fragments endure. Atlas crumbled, but even its fragments will wander the galaxy for millions of years. Borisov dissolved into sunlight, but its dust continues outward, dispersing into the interstellar medium. ʻOumuamua vanished from sight, but it travels still, carrying its mysteries into the dark. If alien civilizations once lived, their fragments too may wander still, unseen, silent, waiting. And if humanity falls, its fragments will join them, part of the endless procession of ruins that fill the Milky Way. This possibility is both tragic and profound. Tragic because it suggests impermanence is universal, profound because it suggests connection. If the galaxy is a graveyard, then humanity's ruins will not drift alone. They will join countless others, fragments of lives, of worlds, of cultures erased, together forming the archaeology of the cosmos. The emotional weight lies in knowing this, that our legacy may not be eternal voices, but silent stones, that our presence in the galaxy may be written not in communication, but in ruins, that what others might one day discover of us is not dialogue, but fragments, and yet, even fragments carry meaning. Archaeologists reconstruct entire cultures from broken shards. Scientists infer the histories of worlds from scattered dust. Perhaps our ruins too will be enough to tell our story. Perhaps silence itself can be eloquent when read with the right eyes. In this way, the emotional weight of interstellar objects is not despair, but perspective. They remind us of mortality, but also of connection. They remind us that even in science there is meaning, and they compel us to ask, what fragments will we leave behind? What testimony will endure when our voices are gone? If Atlas was a tombstone, then so too may Earth one day be. A world shattered, its fragments flung into interstellar exile, a shard drifting endlessly after the planet itself is gone. A relic of a civilization that burned brightly, briefly, and left only silence in its wake. But even in that silence there is truth. The fragments say, "We were here," and that perhaps isn't enough. Silence can feel like an answer, heavy and absolute. But not all silence is emptiness. Some silences conceal beginnings. Some silences are wombs, not graves. The interstellar fragments that sweep through the solar system may not all be tombstones of ruined worlds. They may also be seeds, carriers of water, of organics, of the chemical sparks from which life can arise. This idea is not speculation alone. It is rooted in evidence, in the chemistry of comets within our own system. When the Rosetta spacecraft orbited comet 67P Churyumov-Gerasimenko, it detected organic molecules, glycine, the simplest amino acid, and phosphorus, a key ingredient of meteorites that have fallen to Earth carry amino acids, sugars, and complex hydrocarbons. The building blocks of life are not confined to planets. They are scattered freely across space, waiting to fall upon a surface where conditions allow them to flourish. If this is true within the solar system, it may be true everywhere. Interstellar comets like Borisov, rich in cyanide and carbon monoxide, confirm that alien systems produce similar chemistry. The processes that enrich icy bodies with organics are universal. Ultraviolet light, cosmic rays, and cold chemistry in the outer reaches of disks all conspire to weave molecules of complexity. The galaxy may therefore be filled not only with fragments, but with vessels, ships of stone and ice carrying the ingredients of life across light years. This vision transforms the meaning of interstellar wanderers. Instead of relics of death, they may be couriers of beginnings. Each fragment that passes may be more than debris. It may be a contribution to the fertility of the cosmos. If a young planet receives one at the right moment, in the right conditions, the gift may take root. Life itself may owe its origin to such cosmic delivery. The idea is known as panspermia, the seeding of life across worlds by natural transfer of material. It is not proven, but it is possible. Impacts can eject rock into space. Microorganisms shielded within can in theory survive the cold and the radiation for millions of years. If such fragments cross the gulf between stars, as we now know they can, then life is not only local, it is migratory. It does not remain bound to its birthplace. It drifts outward, hidden in stone, waiting for new worlds to receive it. In this interpretation, the silence of the stars is not the silence of absence, but the silence of creation. Civilizations may be rare, but life itself may be common. Not advanced life, not voices, but microbes, chemistry and beginnings. The galaxy may be a quiet nursery, seeded by fragments like Borisov and Atlas, each carrying a cargo of potential. This perspective brings a profound inversion of the Fermi paradox. Instead of asking why civilizations are absent, it asks whether they are even the right measure of life. Perhaps the galaxy is not empty, but full of biology at its simplest scales, full of oceans seeded by interstellar fragments, full of ecosystems that rise, collapse, and rise again. Civilizations may be fleeting, but life itself may be tenacious. To imagine interstellar objects as seeds is to see the galaxy as a garden, not a graveyard. The comets that crumble, the asteroids that wander, the icy shards that pass unseen, all may be gardeners, scattering molecules across billions of worlds. Humanity in this view is not a lonely accident, but one flowering of a process repeated many times. Others may exist now, primitive and silent. Others may have flourished long ago, leaving ruins. Others may yet arise in the distant future, seeded by fragments drifting still. Even Earth may be evidence of this process. Some theories suggest that life here began with organic molecules delivered from comets and meteorites. If so, then humanity itself is the product of cosmic seeding, the voice of panspermia made articulate. To look at interstellar objects would then be to look at our own origin, to glimpse the couriers that may have carried the raw ingredients of our story. The emotional resonance of this idea is profound. It means that silence is not hopeless, that absence of voices does not mean absence of connection, that even if civilizations are rare, the galaxy is bound together by threads of chemistry. Each interstellar fragment becomes not a tombstone, but a promise that life can begin anywhere, given time, water, and opportunity. Hope lies within this silence because it reframes fragility as fertility. Atlas, in disintegrating, may have scattered dust rich in organics into the solar system. Borisov's tail may have seeded the void with complex molecules as it dissolved. Even ʻOumuamua, enigmatic and sedent, may carry within it chemistry shaped by alien light, waiting for a collision to release it upon another world. The fragments do not need to endure intact to serve their role. Their very destruction can be creative, dispersing seeds into fertile ground. Cosmic hope also lies in the continuity of this process. Civilizations may vanish, but life may always begin anew. The galaxy may not be populated with enduring empires, but with countless cycles of birth and extinction. Each shard that crosses our skies is not only a reminder of mortality, but also a reassurance of continuity. As one world falls, another may rise. As one voice fades, another may awaken. Perhaps this is the answer to the paradox. Not absence, but abundance. Not civilizations, but life itself. Quiet, pervasive, fragile, and everywhere. Humanity may be one flowering among many, one voice among countless others that have yet to speak, or will never speak. In the silence, creation continues. To look at the interstellar wanderers this way is to find not despair, but meaning. It is to see the galaxy as alive, not with voices, but with chemistry. It is to understand that humanity is not alone, not in spirit, but in process. The silence is not neglect. It is a deeper kind of dialogue, written in molecules, spoken in seeds, carried by stones across the dark. And so ʻOumuamua, Borisov, and Atlas become not symbols of endings, but of beginnings. Not tombstones, but couriers. The silence of the stars may yet conceal a chorus too quiet, too young, too small for us to hear, but there, hidden in oceans, in atmospheres, in the fragile beginnings of life. Within the silence lies hope. Hope that the galaxy is not empty. Hope that the wanderers do not carry only ruins, but also seeds. Hope that humanity itself is not alone, but part of a process that transcends worlds, transcends civilizations, transcends even time. The paradox may not be one of absence at all, but of creation unrecognized. And the fragments that drift through our skies may be the proof. the silent couriers of beginnings, scattering life into the dark, whispering that even in settlements the universe creates. At the heart of the Fermi paradox lies a fork in the road, a divide that cannot yet be bridged. The interstellar objects that have passed through our skies, ʻOumuamua, Borisov, Atlas, embody this divide with haunting clarity, for there are two possibilities, and neither offers comfort. The first possibility is that humanity is alone. The sameness of the stars is not a mystery, but a fact. The galaxy is vast, rich in planets, fertile in chemistry, yet barren of civilizations. In this vision, ʻOumuamua was only stone, Borisov only ice, Atlas only a fragile cometary shard. The silence is not aftermath, it is truth. If so, Earth is not merely rare, it is singular. Life here is not a pattern, but an anomaly. Civilizations do not speak across the void because there are none to speak. Humanity's destiny is not to join a chorus, but to sing alone. The implications are staggering. If Earth is the only cradle of intelligence, then survival becomes the most sacred responsibility. For if humanity fails, the universe may lose forever the one voice it has. The silence would not be warning, but oblivion. This loneliness would not diminish the cosmos, it would magnify it. Every interstellar fragment would remind us of the countless worlds that could have been alive, but were not. Every passing shard would testify not to fragility, but to emptiness. The paradox would not be tragic, but absolute. And yet, there is the second possibility, that humanity is not alone, that the silence is aftermath, not absence, that civilizations have risen and fallen, leaving only fragments to wander between stars. In this vision, ʻOumuamua might be more than stone, and Atlas, more than cometary dust. They may be relics of worlds undone, the remnants of cultures erased by their own hands, or by forces beyond them. The silence of signals would be explained not by loneliness, but by mortality. The galaxy would be filled not with absence, but with ruins. This vision is equally profound, equally unsettling, for it suggests that civilizations do not endure. They collapse before their voices can cross the void. They vanish before they can fill the galaxy with presence. Their ruins become indistinguishable from natural debris. Their artifacts eroded into ambiguity. Survivors are rare, tombstones abundant. If this is the truth, then humanity is not alone, but it is fragile in the same way, subject to the same fate. Both possibilities carve deep into philosophy. If alone, then Earth is the greatest responsibility in the universe. If not alone, then Earth is only the latest in a long sequence of fragile worlds, destined to scatter fragments into silence. Either way, the interstellar objects carry weight far greater than their mass. They become symbols of the divide, natural or artificial, emptiness or aftermath, solitude or mortality. The split is not merely academic, it shapes how humanity imagines itself. To believe in aloneness is to believe in uniqueness, in the singularity of human thought among billions of stars. To believe in ruins is to believe in connection, but also in tragedy, that others lived, struggled, perhaps dreamed and fell. Both require humility, both demand reflection. The silence of SETI deepens the divide. After decades of listening, no signals have been found. This seems to favour aloneness, and yet the abundance of interstellar debris argues the opposite. If systems are so common, if fragments are so plentiful, then why not civilizations? Perhaps they existed, but they did not endure. The paradox sharpens with each discovery. This is the essence of the philosophical split. Both answers terrify. Both answers demand new ways of thinking about life, meaning and survival. If alone, then the weight of existence rests on humanity's shoulders alone. If not alone, then the ruins are warnings, and humanity stands already within their shadow. And yet, there is a subtlety in the silence. The galaxy may not be one or the other, but both. Perhaps life is rare, but not unique. Perhaps civilizations exist, but they collapse. Perhaps some interstellar fragments are only natural, while others are ruins. The silence may be not a singular answer, but a spectrum of truths. In this way, the interstellar objects embody the paradox more powerfully than any equation or telescope. Each fragment forces the question. Each one demands that humanity confront the fork in the road. Alone or not alone? Natural or ruin? Silence of absence or silence of aftermath? Neither path offers certainty, neither path offers comfort, but both offer meaning. For whichever is true, the fragments remind us that existence itself is rare, fragile and precious. Whether we are the only voice or one among many silenced, our survival matters, our story matters. And so the philosophical split remains unresolved, carried in every interstellar shard that drifts past. They are questions disguised as stones. They are mirrors reflecting possibilities too vast, too humbling, too terrifying to answer fully. To hold either possibility in the mind is to stand on the edge of awe. For in both solitude and in ruins, the cosmos becomes not emptier, but deeper, filled with meaning, heavy with silence, alive with questions that humanity has only just begun to ask. In the vastness of the cosmos, events unfold on scales of billions of years. Stars are born, live their luminous lives, and die in cataclysms that echo across light years. Planets coalesce, collide, and sometimes harbour life for brief instants before fading into silence. Against this immensity, the passing of an interstellar fragment through our skies is an event so fleeting it might seem trivial, yet in its brevity lies its meaning. 3I Atlas is already gone. Detected in late 2019 by the Asteroid Terrestrial Impact Last Alert System, its path marked it as extraordinary, an object not bound to the Sun, but to the galaxy itself. For a moment, it was a messenger from another star system carrying with it the scars of deep time, but its life in our view was short. Under the pressure of the Sun's heat, it fractured, disintegrating into dust and shards. By the time telescopes turned their full attention to it, it was already fading. Today, its fragments are lost, wandering invisibly into the interstellar dark. And yet, its story remains. Atlas was not the first interstellar visitor, nor will it be the last. It joined ʻOumuamua and Borisov as part of a growing pattern, a revelation that the solar system is not an island. It is a harbour briefly visited by travellers from afar. For eons, these wanderers slipped past unseen. Only now, with the rise of telescopes like Pan-STARRS and Atlas, are we beginning to notice them. Their presence changes how we see the universe. For centuries, the night sky was imagined as distant, remote, unchanging. Planets have circled quietly, stars shimmered with permanence. But the discoveries of the past decade reveal a galaxy that is restless. Material does not remain bound to its origins. It is ejected, scattered, set adrift. The void between stars is not empty. It is a sea filled with travellers, and each one carries history. ʻOumuamua, with its strange trajectory and acceleration, challenged our imagination. Borisov, with its glowing coma and tail, reminded us that cometary chemistry is universal. Atlas, in breaking apart, revealed fragility, impermanence, the violence of interstellar exile. Together, they transform the way we think about space. The galaxy is not still. It is alive with motion, exchange, and loss. The present moment is significant because it is the first time in human history that such wanderers have been recognized. For billions of years, they came and went unseen. Now, with instruments capable of detecting their faint light, humanity has begun to catch glimpses of this hidden traffic. In time, with new observatories like the Vera C. Rubin, we may see dozens, perhaps hundreds more. What once seemed extraordinary will become familiar. The solar system will be understood not as isolated, but as a crossroads. And yet, even as detection grows more common, the mystery deepens. Each interstellar object is fleeting, its window of study brief, its secrets incomplete. ʻOumuamua left unanswered questions about its nature. Borisov gave us only a glimpse of alien chemistry. Atlas dissolved before it could be examined in detail. Each discovery sharpens the paradox rather than resolving it. We are left with fragments of stories, partial truths, reminders that understanding is still beyond reach. But perhaps that is the lesson of the present moment, that we are standing at the threshold of a new awareness. Just as early astronomers first realized that stars are suns, that galaxies are vast islands of light, we are now realizing that interstellar fragments are part of the fabric of the cosmos. Their discovery is not an end, but a beginning, a door opening onto questions we are only now learning how to ask. The presence of these objects is also a reminder of scale. Civilizations may rise and fall, planets may endure or be destroyed, stars may live and die, but fragments persist, wandering for eons across the galaxy. Atlas is gone to us, but it continues its journey, its dust dispersing into the interstellar medium, its shards carrying their story far beyond our sight. In this way, the present moment connects us to the deep past and the deep future. Each interstellar visitor is not just a discovery, it is an encounter with time itself. And so, even as Atlas fades, its meaning endures. It shows us that the galaxy is restless, that the void is not empty, that silence is not absence. It reminds us that we are only beginning to notice the travellers that pass us by, each one carrying secrets we have not yet learned to read. The present moment, then, is fragile, fleeting, and immense. It is a reminder that we are at the dawn of a new chapter in astronomy, where the galaxy itself becomes a site of excavation. Atlas is gone, but its passing tells us that there will be others. The sea between stars is filled with wanderers, and humanity has finally opened its eyes to their procession. In the silence of space, this is what the present moment offers, not answers, but awareness. A recognition that we are not surrounded by emptiness but by motion, that the galaxy is not barren but alive with fragments, that each passing shard, however brief, is a reminder that the universe is not still, it is restless, but it is permanent and it is watching. The question that Enrico Fermi once asked, "Where is everybody?" has echoed for decades, a haunting chorus behind every attempt to search the skies for company. Humanity has listened for signals, scanned for patterns, waited for voices to cross the void. And yet, no voice has ever arrived. The radio sky remains empty, the stars remain silent. But perhaps the paradox will never be resolved by sound. Perhaps it is not a message in radio or laser that will reveal the truth, but something quieter, something humbler, shards of stone and ice drifting through the dark. ʻOumuamua, Borisov, Atlas. Each was a fragment from beyond, silent, untranslatable, gone before its story could be fully told. Yet each carried a truth, whispered in absence, that planetary systems are common, that debris is abundant, that the galaxy is restless, and perhaps too that civilizations rise and fall, leaving ruins adrift in eternity. The Fermi paradox then may be answered not with dialogue but with archaeology, not with voices but with fragments. Civilizations may never endure long enough to fill the galaxy with sound. Their broadcasts may fade. Their worlds may collapse, but their remnants will drift on, mute, ambiguous, and eternal. A shard passing silently through another star system may be all that remains of a people who once looked outward and wondered, as we do now. This realization cuts in two directions, terrifying and profound. If the fragments are only natural, then perhaps humanity is alone, and the silence is emptiness. If the fragments are ruins, then we are not alone, but part of a pattern of fragility, one more civilization destined to scatter dust into the dark. Both possibilities weigh heavy, both force humility, and yet, within that weight, there is meaning. For the fragments remind us that impermanence is universal. Stars collapse, worlds fracture. Civilizations dissolve, nothing escapes time. But even in impermanence, something endures. A shard carries memory without language. Dust carries chemistry without intention. Silence itself carries truth if we learn to listen. Perhaps the true question is not where everybody is, but where we will be. What will humanity leave behind? A galaxy filled with voices, or only ruins? Will our legacy be conversation, exploration, endurance? Or will it be silence, broken only by fragments drifting without name, indistinguishable from those that came before? The answer is not yet written. The future remains open, fragile, and vast. What interstellar wanderers teach us is not despair, but perspective. They remind us that time is long, survival is rare, and meaning is something we must carve for ourselves. To endure is not guaranteed, to vanish is not inevitable. The choice lies in what we do now, in the present moment, on this small planet lit by one ordinary star. Perhaps one day another civilization will stand as we do, gazing into their night sky, watching a faint visitor slip past. Perhaps that visitor will be ours, a fragment of Earth, a probe, a shard drifting silently, carrying within it the last testimony of our world. To them we will not speak in words, but in sounds, and in that sense they may see themselves. The Fermi paradox may never be answered cleanly. Its resolution may be scattered, fleeting, whispered in the passing of interstellar objects, each one a reminder that the galaxy is filled with beginnings, with endings, with ruins and with seeds. Civilizations rise, civilizations fall, and in the end, only their fragments drift between the stars. What remains to be asked is not whether we are alone, but whether we will endure, whether we will write our presence in voices that last, or in ruins that wander, whether we will fill the galaxy with connection, or leave behind only silence. In the quiet procession of ʻOumuamua, Borisov, Atlas, the universe has already spoken, not in signals but in shards, not in language but in silence. And in that silence, the cosmos whispers the same truth to every world, every civilization, every fragile mind that dares to ask, "You are not permanent. Choose what you will leave behind.